And yeah. All right, so you guys, just a little bit of summary. We were talking about monitors. What do you remember about monitors? Give me another word for like a monitor. Yeah, it's a test, exactly. So when we're talking about monitors, keep in mind that's a test that that onboard diagnostic system runs. It runs the test to determine if there's a problem with itself or not. See, so that's kind of where we're going. And so like on this one, I just wanted to just jump back in there. We're looking at the monitors right here. The misfire monitor test is complete. The fuel system monitor test is not complete. So, and to be honest, this one probably doesn't even have, it's probably not equipped, but it might be actually. So let's just say that the onboard OBD II in this case needs to monitor the fuel system. Maybe it needs to check like the fuel rail pressure sensor, or if it has any sort of fuel pump control module. If it says not complete, what do you think that means? Did it pass or did it fail? It didn't necessarily fail. That's the thing. It just didn't run yet, right? So the reason I really like to tie that in is if you're working on the car and you see that it has a code, a DTC set, that means the monitor ran and failed. And so when it says not complete, that doesn't mean that it's good or bad. It just means it doesn't know because it hasn't taken the test yet, right? So one of the things that we're going to get into, it talks a lot about enabling criteria. And you're like, what the heck is enabling criteria? Well, that means like all these pre-programmed conditions have to be met. So maybe it can't run the fuel system test until it's been running at least 15 minutes at freeway speed, 55 to 65 miles an hour. So if you only drive the car around the little surface streets right here, is that test going to run? No, because you got to be at least 15 minutes at 65 miles an hour, whatever the enabling criteria is, right? So sometimes we get these cars and they're not ready for smog, or they're cars where it's hard to tell whether you fix the problem or not. A lot of times what we need to do is drive it so that the enabling criteria is met, so that it'll run the test and tell you it either passed or failed. But a lot of times technicians don't really know how to drive it. It's like, do you make sure it's a cold start, or do you drive it on the freeway, or do you drive it in traffic, or what do you really do? You need to be able to look up that enabling criteria, and it's there somewhere in all data or some sort of service info. It'll tell you these are the enabling criteria. You need to do A, B, and C, and X, Y, and Z, and then the test will run, right? So it's kind of unique. Cool. So that's kind of what we were saying. And then you can see when it's not ready or incomplete, those are two different ways it could be listed on the scan tool, and it is not really ready for smog. But now let's talk about more how the actual ECM is going to do its onboard diagnosis. So if you look at this right here, the PCM, everybody clear on what the PCM is? We talked about it last week, right? Powertrain. So you could, when you see PCM, if you want, you can switch it to ECM in your brain. It's an engine control module, or it's a powertrain control module, because it controls engine and transmission, but it doesn't really matter. The book has to pick one. You can't be like ECM or PCM every time, so they pick PCM. I'm good with PCM. PCM makes sense. Not necessarily true in all the cases, but we're good. It's just a generic, this is the powertrain control module that monitors, right? So the PCM monitors the circuit for voltage change when the component is operated. What the heck does that mean? Well, let me help you. If you look at this is your PCM right here, and it has transistors. And so if we were to go way back to electrical, you'd remember transistor is like a solid state control device. It can turn a circuit on or off, right? So the PCM controls. Remember how I threw that kind of nasty whatever AirPod or whatever you call the things at Mason, and he moved, right? Mason's brain sent signals in his nerves to contract muscles and move, right? Well, the PCM does that too. So the PCM is actually going to control this ignition coil. Yeah, like the nervous system. Exactly. So in this injector or in this coil, the PCM can command the injector with 12 volts in ground to spray fuel. Cool. You could do that. Or it can command, to be honest on this one, I think it's actually commanding ground right here. I think the PCM can provide ground to this coil, and I'm kind of fibbing to you, but no, I'll tell you the truth because we're going to be into ignition soon enough. When the PCM wants the coil to fire, it actually takes the ground away. All right. So I was going to say it can give ground to make it fire, but the truth is the PCM gives ground to charge it, and then it takes ground away to fire it. But ultimately, you still see the PCM's controlling it, right? So the PCM is controlling these transistors. If it wants to fire the injector, it provides a ground. If it wants to fire the coil, it takes the ground away. But ultimately, the PCM's controlling it. And so we know the PCM does that type of work, like your brain controls your muscles, right? But also, the PCM is actually monitoring the voltage right here. So let's just say the PCM provides a ground for the injector. If it provides a ground for the injector, it can actually sense if that injector is fired or not. It can watch the circuit, right? So if let's just say this injector is open internally, it has open coil, the voltage that it monitors inside the ECM or inside the PCM will not do what it thought it would. Make sense? So if this coil in this injector was good and it's getting 12 volts, and then the ECM provides a ground, this should become 0 volts inside. But if, let's say, for some reason it doesn't drop all the voltage, or maybe it continues to show 12 volts or something, it knows that there's something wrong in the circuit. Does that make sense? It doesn't, however, know if the problem is right here or down here or down here, or it could be here or it could be there. Cool? So in the onboard diagnostic system, it does some level of self-diagnosis. So you might get a code, injector circuit number 1 open or short to ground. And you're like, well, where's the open? The system doesn't know. It doesn't have the ability to know. It just knows when it fires that injector, it should get this reading, but it didn't get that reading. So it knows that there's either an open or a short to ground. Make sense? Exactly the reading that it should get, well, it depends. It depends on what the internal resistance is after that transistor, So I'm giving you like a generic. It knows, it's programmed to say, when I fire the injector, I should get this voltage. But if I didn't get this voltage, that means there's a problem in the circuit. So what do you think the PCM is going to do at that point? It just detected a fault. Yeah, exactly. A code is set, check engine lights on. So the mechanic gets the scan tool, plugs it in, is like, oh, injector circuit 1, open or short to ground. I'm like, what's O'Reilly's and AutoZone and these places going to sell you? It said an injector in the code, so you sell an injector, right? But my point to you is the way the onboard diagnostic system works, it doesn't actually know that it's the injector. It could be the injector. It could be an open coil inside the injector, but it could be an open in this wire here and this wire here. It could be a bad connection here. It could even, in some rare cases, be in the circuit inside the ECM. So when you get that code, the possibilities most of the time are going to be the ECM or the PCM itself, because it's got a little printed circuit board, the little green board with the little circuits drawn on there. It could be that. It could be a connection at the ECM. It could be this wire. It could be a connection at the injector. It could be the actual injector circuit could be open, I acknowledge. But it could also be a connection at the positive side. It could be an open in this wire anywhere on the 12 volt side, right? It could even be, let's just say, a mouse, right? A mouse got in there, made a nest, and was like, ooh, a blue wire, blue raspberry, my favorite. Oh, no, 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 no. And then you got a code for your injector. O'Reilly's or AutoZone sells you the injector, but in the meantime, it's like, I put the injector in, it didn't fix it. Now I need to take it in. Like, you were out of line as soon as you just read the code and put a part in. Make sense? It just doesn't work that way. Now, I'm not going to knock the OBD system. I think it's amazing because if we didn't have onboard diagnostics and this PCM wasn't monitoring its own voltages, what the heck, where would you even start? You know, the car would come in, and if the injector wire is chewed, what do you think the symptom is? Anybody think they can guess? If one injector wire gets chewed and that one injector goes to one cylinder and that one cylinder no longer gets fuel, yeah, misfire, shaking, misfiring. And you'd be like, oh, it's got a misfire. Then you could do some of those tests from the first thing that we did, right? You could do the power balance. You could do some of the basic, like misfire testing. Then you might even do compression, be like, the compression's good. You could do spark and the spark is good. Then you go into fuel and be like, yeah, it's got a misfire, but it's got a problem with the injector. So it gives us a big jump because we got a code and it says injector circuit number 1. So we're not really looking at 2, 3, 4, 6, 7, and 8. And we're not really looking at the O2 sensor. We're not really, we're like, hey, it's in the injector circuit, but we don't necessarily know that it's the injector. See what I'm saying? So like if I would reword that, it'd be like this. You're looking for somebody's house. The onboard diagnostic system setting a code will tell you that it's in the United States, that it's in California, maybe even potentially the zip code. Then after that, it's up to you to really like test the system and check the streets and actually physically locate the house. The onboard diagnostic system doesn't give you the whole address. It gets you maybe just as far as city, state. You got to actually find the address. Make sense? So we start with that. Of course, we start with that. Check the codes. And if you got injector circuit number 1, you're forgetting about the whole other 49 states in the US. We don't care about those 49 states. We're at least here. Then maybe we at least know what city we're in, but you still have some work to do, right? So in unit 3, we go into like, how would you determine if it's the injector, if it's this wire, if it's that wire, if it's the ECM? So we got a lot more stuff to do after that still, but it's better than checking everything in every state. Cool. And similar with the coil, ignition coil. If you had an open ignition coil or you had an open wire going to the ignition coil, that'll set a different circuit. It's a different code. It's usually like primary ignition circuit, open or shorted. So at least you know, like, hey, it's in, and it'll tell you what cylinder. So you got a pretty good jump right there. But you guys understand the ECM is the one doing the onboard diagnostics. The ECM is programmed to say, when I do this, that voltage should be that. And if it's not, I set this code. Cool. Also, like it can detect a misfire as well. So if we were to look at, hey, we think it's trying to detect a misfire, we could look at, let's just say, probably crankshaft, camshaft position sensor, and it'll know where your crankshaft, well, we'll focus on crankshaft. If your crankshaft is speeding up on cylinder 1 when cylinder 1's firing, and then it's speeding up when cylinder 2 fires, and then it slows down when 3 fires, it'll say like, why is it going slower when cylinder 3 is firing, and then number 4 fires and it speeds back up? It can see the change in speed and therefore determine its cylinder number 3, right? So back right here, we were talking a whole lot about how it monitors the circuit, right? That's a circuit type DTC. I like circuit type DTCs because when a circuit DTC sets, like, I know that I'm in the circuit, right? I'm testing the wires, I'm testing voltages. I might even, be able to do like an active test with the scan tool where I fire the injector manually. Makes sense? But then there's other types of codes, like kind of what I was focused on here. This is more of like it's almost more of like a performance related DTC. A misfire, if it's the cylinder number 3 misfire, there's no wires monitoring voltage for cylinder number 3, right? But kind of like what I was describing, the crankshaft position sensor speeds up when cylinder 1 fires. It speeds up when cylinder 2 fires, and it slows down when cylinder 3 fires, and then it speeds up when cylinder 4 fires. The PCM is programmed to say, we're monitoring that crankshaft position sensor. We noticed that it's slowing down when cylinder 3 fires. Does that sound like a problem with the crankshaft position sensor itself? No, so it doesn't set a crankshaft position sensor code. It sets a cylinder 3 misfire code because it's pretty sure that cylinder 3 is not firing because it keeps slowing down pretty consistently when cylinder 3 should be speeding it up. Make sense? So that's a different type of code. The OBD system still set the code. It's just not necessarily monitoring voltage like this one. It's more advanced. It's actually monitoring the crankshaft speed through the crankshaft position sensor. Cool. So if you got a code for cylinder number 3 misfire and you rolled into AutoZone and you said, hey, I got a cylinder number 3 misfire, what do I replace? It doesn't list a part, does it? They're probably going to sell you spark plugs. Then if that doesn't fix it, they might sell you coils. Then if that doesn't fix it, they might sell you injectors. Then if that doesn't fix it, they'll be like, well, the engine's got to be no good. But see, so like, I'm just being really honest though. It's the truth. When it's a misfire code or one of these more performance type codes, it doesn't necessarily list the part and really people don't know what to do. So the way that we'd go about that is more like strategy based. What could cause a misfire? It could be no compression. Now you all know how to do compression tests. If you do a compression test and it fails the compression test, don't you dare be putting spark plugs in that car to fix that. That's not the problem. You measured it. You know that's not the problem, right? And then it could be a spark problem, and we're going to cover that. And it could be a fuel problem, and we're going to cover that, right? So those are the main three, the three main things that could cause it. But you know what the code says? Cylinder 3 misfire. That's it. You're on your own. Then you got to do some stuff. Another fun one is like, you ever seen, they don't call them infomercials anymore, but there's a social media pop up one time. It's probably been a few years, but it was for like it was just an OBD2 dongle that you plug into the DLC, the Daylink connector, and it gives you codes, and they're selling it as like my buddy or my mechanic buddy or something like that. And they were, they had testimonials from mechanics and saying like, oh yeah, this is what we do in the shop. You just plug it in, it tells us what's wrong, and we're going to charge you $100 or $200 or $500, and you can get it yourself. And there's all these things like, I plugged it in and it told me what to replace, and I replaced it. And so I don't always do this, but this was like when I wasn't that busy. I went out and I said, I've got a code. P0171 fuel trim lean. What part do I replace? I just waited. No response. Because when you get a code like that, fuel trim lean, there's no sensor, there's no part, there's nothing listed. You're like, what the heck do I do? This mechanic buddy or whatever the name of it has no ability to give any more information than the onboard diagnostic system gives, right? So we're going right to the source. The computer monitors these things in different ways. Fuel trim is way too hard to explain right now, but just know there's like hundreds of different tests this thing is going to run. And when it fails, it sets the code, and the code doesn't exactly tell you why it failed. And when it doesn't run yet, because let's say it's like one of the next things coming up, if it's a bad catalytic converter, you guys know what those cost, right? Talking about that a little. Thousands. Yeah, that to do it legit OEM, where it's actually going to be passing in this particular state. In the other 49 states, you can get whatever you want off of eBay. They probably won't last that long, but in this state, you need to really do OEM to pass smog legit. Thousands. It's true. It's true. Go ahead.
If the fuel system is running too rich, could it also be the patent?
No, it can't be, but potentially if it's running too rich, it could be a problem with the O2 sensor, but it could be like 10 other things too. So when we talk about the fuel system, that's a big thing we got to cover. Fuel trim, I'd say, is like one of the number one things people have a hard time understanding. So we're going to cover that like in its whole day, that thing. So here's the thing. If you go to buy this car and it's got a bad cat, and the customer gets the little mechanic buddy scan tool and they clear the code, you come in, you look at the car, the check engine light's off, right? So you're like, oh, this car's good to go. No check engine light. Well, what if you were to go in and check the monitors and it were to say incomplete? You think that you have a little bit more information now? You'd be like, it's incomplete. Did you just clear the codes? And they'll be like, oh, well, okay. Do you want to drive it until this monitor sets? And if the monitor sets, I'll buy it. But then you usually see them choke up, and then they don't want to sell it to you. It's it's easier to sell it to somebody else who knows less. You know, once you show your cards that, hey, I understand that this monitor is not set, you know, in this state, it's on the seller's responsibility to get the car to pass smog. So if they sell you the car and you already figured out that it's not going to pass smog, they're going to be like, oh, no, you're going to come back and make me fix this catalytic converter. I'm going to sell it to some other ding dong. That's what they're going to do. All right, cool. All right, so let's look at this one. The heater in the O2 sensor quickly warms up the sensor so that the signal can be created by the metal within the sensor. Okay, let me help you understand. We talked a little bit about it in the lab, but heated oxygen sensors, for example. An oxygen sensor is not accurate till it's up around like 600 degrees, sometimes a little higher. So right, if it's 300, that sensor's worthless, so the PCM ignores it. So what do? We actually put a heater on one side of it, and then when you first start the car and it's cold, we'll tell the heater to turn on to heat up the metal in the sensor. Now the ECM or the PCM is going to actually monitor the heater side. So if you run a heater, that heater is going to consume a certain amount of voltage, and it's probably going to flow a certain amount of amperage. Some ECMs can monitor the amperage. Most ECMs will monitor the voltage through voltage drop. Something we definitely cover a lot next time. But if that heater is no good, it's not going to drop the correct amount of voltage. It's going to say, hey, heated oxygen sensor circuit, bank 1, sensor 1 open. And you'd be like, oh, okay, I got a problem with the oxygen sensor heater circuit. Could it be the heater? Yes, and that's the most common. Could it also be a connector? Could it be a chewed wire? Could it be a bad connection? Could it be a open an ECM? Yes, so we want to do some basic testing, right? But that's only one side of the oxygen sensor heater, and that happens to be the side that's more of an output, right? The ECM doesn't sense the heater. The ECM commands the heater on, and the heater does work. The other side of the sensor is actually an element that measures the amount of oxygen in there. So if you look, high voltage is rich on this sensor. Low voltage is lean. So 800 means it's running a little rich. A little rich means not enough oxygen. So like too much fuel, not enough air type of thing. It could be either. It could be literally too much fuel, or it could be not enough air. But the balance is, it's off. It's too much fuel, not enough air. But then if you notice, then all of a sudden it swings down here to lean. Low voltage on this type of sensor is lean. And so now it's got too much air, not enough fuel down here at 200. And then it goes up, and then it goes down, then it goes up and down. And actually this right here is normal. Our upstream sensor should be going up and down because our computerized system is trying to get our fuel ratio stoichiometric, right? It's trying to get it perfect, but it's hard to do that. So it's like, I'm going to spray this much fuel. And then the sensor's like, hello, too much. And it's like, back it off a little bit. And it's like, oh no, that was not enough. And then it sprays a little bit extra, and it sprays a little bit less, and sprays a little bit more, right? But actually, on average, if you were to average the 800 and the 200, it'd come out to, you know, somewhere around 450. And that the average is good. So on average, we're running stoichiometric, but in reality, we're rich, we're lean, we're rich, we're lean, we're rich, we're lean, right? That's what the sensor does. So the oxygen sensor is an input to the PCM, and it says, hey, you're too rich. Oh, now you're too lean. Now you're too rich. So let's just say, hey, you're too rich. The ECM is going to, what do you think the ECM is going to do to counter that? What do you think the ECM is going to do to fix that? If it's too rich, rich means too much fuel, not enough air.
It's gonna send a signal to the injector
To spray less. Bingo. That's a major function of the PCM, right? It got information. It got information from the sensor. Hey, you are rich. As a result, it takes that information. It looks at its programming, which was written by the engineer in the tune, and it says, oh, yeah, back the injectors off. Don't leave them open so long. Decrease the injector on time. And then it once again starts looking at the sensor, and it sees the result, right? It's like leaning way out. And then it's like, okay, whoa, that's enough. That's too lean now. What should we do to get it off of too lean and back to normal or rich. Add more, boom, and it does it, right? So it's this cycle. It's this cycle. The input is the sensor. The output is the injector. The PCM is obviously, getting information and giving a command, right? So that's what it does. Now, this one's going to take it a step further, though. If you look, this is your exhaust stream right here. Your exhaust was rich, then it was lean, then it was rich, then it was lean, then it was rich and lean, right? That's kind of crazy. Do you know what a healthy catalytic converter will do for you? It'll smooth it out. Exactly. So a catalyst is a chemical reaction. When stuff is too rich, that means there's not enough oxygen, right? The catalytic converter is going to actually provide oxygen and balance it. Then when it's too lean, the catalytic converter is going to absorb oxygen. So coming into the catalytic converter, we have stuff all rough. It's up and down and up and down, up and down. That's normal. The rear O2 sensor is after the catalytic converter. That means it's checking the oxygen level after the cat. If the cat's working good, the cat absorbed it when there was too much and it provided it when there was not enough. And so actually it should look like this. You see how this line looks kind of lazy? That's good. That's your cat cleaning it up. Make sense? It's just smooth. It shouldn't have the peaks. Now it can go up and down a little bit. That's normal. But what it shouldn't look like is this. What would you say those two look like? The same. So what's the cat doing? Okay, so I'm going to give you a code. You're going to remember this code because you always do. P0420. But that's, no, catalyst low efficiency. So now we're going to dive down to this one to make sure you really are grasping the monitor and the input and the output, right? If it's like this, we can presume this sensor appears to be reading well. If this sensor starts to do some weird stuff, we may set a performance code for that front bank 1, sensor 1 oxygen sensor. Then you'd be like, I got a code for the O2 sensor. It could be the O2 sensor if this waveform looks weird, but it's also happened where the exhaust manifold cracks, and when the manifold cracks, it sucks air in and then it pushes air out, and then you get oxygen that's coming in a weird way and the sensor's like freaking out, and then it sets a code for the sensor, and then you replace the sensor and it doesn't fix it, and come to find out it was because there's a big exhaust leak right near the sensor. Okay, makes sense. So we do get these codes that specify the O2 sensor, but you got to understand the way that the PCM is doing it, it's looking at this voltage reading. So this is your introduction to waveform. All a waveform is voltage over time. It was 800, and then this is time. After 1 second, it went from 800 to 200. And then it went out a second later, it was back up at 800. And then a second later, it was still close to 800. But then 1 second later, it was at 200, right? So a waveform is just what your voltage does, but over time. If you were to use your meter, you'd see the meter be like 800. And then it would boop, 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 to 200 and then boop, to 800. But you can't really get an image of what the voltage is doing. So this graphs it for you. This graphs it and kind of records it, right? So we're looking at a waveform here. This is a reasonably good, I mean, this one here is a little sloppy, but this is a reasonably good oxygen sensor reading. But can I trust it? I don't really know. If it doesn't set a code, I'm pretty happy. There's some times where it doesn't set a code and it's wrong. So there's tests that we could do. Like one of the tests that I would do, I would actually pull a big vacuum line off, like maybe the brake booster. If I pull a big vacuum line off, it's going to suck a lot of extra air. If I suck a lot of extra air, that's going to be lean. I should be able to peg this sensor at 200 and it should mostly stay there. It should be like, boo, flat line. And it should, because I just added a lot of extra air. Now, if I pull the vacuum line off and the sensor doesn't really respond right, I'm going to be like, what is up with this sensor? Hello, I just added a bunch of air. Why aren't you responding, right? So I could kind of, you might even say, interrogate the suspect.
Well, if you're getting closer, though, wouldn't they start adding more fuel?
Not right away. So the sensor itself is going to flatline mostly, right? At least for a bit. And then, yes, it should start to add fuel and it should pull it more towards center. But with your eyes, if you're seeing this graph live, you should be able to catch, like, is it normal or is it abnormal? If you pull it off and it doesn't even really seem to peg it at all, I'd be like, I don't know about that oxygen sensor. Sometimes oxygen sensors get coated with contaminants. And then, yeah, there's a whole bunch of oxygen in the exhaust, but it can't really sense it because it's coated with junk. And then you'd be like, I don't think this O2 sensor is good. Cool. But this looks reasonable. However, and this looks actually really reasonable. So I'd say we could be pretty good, but this sensor could set one code. In fact, the front O2 sensor can set several. It can set a code for the heater circuit. Now you know why I like the circuit codes. If it's the heater circuit, it's not that complex. It's a problem in the electrical circuit. The heater is bad. The wire is open. The connection is no good, right? Whereas if it's a bank one, sensor one, oxygen sensor performance, that's not saying it's in the circuit. That's more saying like, hey, the waveform is weird. The waveform doesn't seem like in spec. Then you're like, well, is it the sensor? Is it an exhaust leak? You know, it's a little bit more, there's more possibilities, and you might have to do a little bit more advanced testing. Whereas if it's a circuit code, like I'm right down to the meter, the voltmeter, and I'm checking voltage and figuring it out, right? Then you get into these other codes like the P0420. That's kind of like a performance code, but it's comparing this sensor to the rear sensor. So the front sensor to the rear sensor are compared. I'm going to say most of the time when you set that code, if you graph the front and the rear, you can actually see, hey, they look kind of the same. If you want, you could do some of the interrogation tests, pull the vacuum line and whatever, see if the sensors respond. But most of the time, it's not a problem with the sensor. Like if the sensor had failed, why do they look the same? You know, a sensor fails, it could be flatline. A sensor fails, it might not go back and forth as much. But if a sensor fails, why would it fail in a way where it's going to replicate? You know what I'm saying? Like that'd be just, somebody'd have to explain it to me where this sensor fails in a way where it happens to just mirror the other sensor. It doesn't make sense. So if I get this code, I'm already suspecting the catalytic converter. And that's why I don't go for the oxygen sensor. Now, some manufacturers have had programming updates and issues and stuff like that. But to be honest, it's a long shot. If you got that P0420 or a 430, you're probably looking at a cat. You could by all means do a little bit more diagnosis. There's some exceptions. Like if this one's going back and forth a lot, that's normal. If this one's going back and forth a lot, it's either A, because the catalyst is degraded, or maybe you have an exhaust leak and it's sucking air in and it's making it go up and down more than it should because it's got an exhaust leak. But for the most part, I'm all over the cat. I think the cat's probably no good. Now, why is the cat no good? That gets like way more advanced. So if you diagnose that the catalytic converter is no good because you looked at these sensors, right? And to be honest, the onboard diagnostic system already kind of did the diagnosis for you. It set the code, P0420. P0420 doesn't say oxygen sensor no good. P0420 says catalyst low efficiency. So like that's different. That's a different part. That's the catalytic converter. You're already in the ballpark. But why did the cat go bad? Then you have to understand misfires that have raw fuel in the exhaust will kill a catalytic converter in hundreds of miles, if not, thousands of miles potentially. But a cat that's getting raw fuel is not going to last tens of thousands of miles. So if the cat's gone bad, maybe it's because you have raw fuel going into the cylinder. You could put a cat in there, but if you don't fix the raw fuel, what's going to happen to the next cat? Same thing, right? So for you guys, we're mostly focused on the initial diagnosis, but don't totally put out of your mind the root cause. Like this part failed. Sometimes parts fail, but like, why did this part fail? Is it possible that this sensor is inaccurate, reading more lean than it really is, and telling the ECM to add more fuel than it should? That fuel is going to be very hard on the cat. That could, don't want to make this dark, but that could kill the cat prematurely. The catalytic converter. Okay, so that's kind of like the OBD II system doesn't tell you that, right? That's another limitation of OBD. The OBD II system doesn't say P0420, but also you should probably check the front O2 sensor because it might have killed this cat, and that's why it set the P0420. It just sets the P0420, that's it. It's on you, the technician, to look at more like cause and effect, like why did this situation occur? You want to know the most common one? 250,000 mile car, probably burned some oil. Oil getting on the catalytic converter is going to destroy that cat. So if you're not really understanding what I'm saying, you'd be like, oh, it's got a code for the cat. I looked at the graph. It looks like the cat's no good. Sell the cat. The engine still burns oil. What's going to happen to the next catalytic converter? It's going to be no good again, right? So like when you get these higher miles cars and people are like, oh, it's good. It's only got 250,000 miles. I'm kind of like, yeah, if you don't have the money and you got to get around on a hoopty like that, like I get it. I've been there too. But if you think that you're going to really fix up that 250,000 mile car to be indefinitely reliable, like you're going to have a bad cat and you're going to want to put the cat in it, but are you going to want to put the cat in it and also rebuild the engine? In which case you got more money into that car than you paid for it on those two repairs alone, you see? So like, I'm a little snooty with that. I told you all the cars are junk. They're just junk. Sometimes the newer cars have other issues, and I acknowledge that. But once a car's got that many miles on it, you're really just limping it by. You're just fixing things as it needs to be fixed. If you think it's going to be like a great, amazing car, I don't think so. I just don't. Even you could throw tons of money into it. It would cost you probably 10 times the price to replace every part on the car one at a time, individually as it fails, than it would to buy a whole new car and get 200,000 miles out of that car. See what I'm saying? Just take it for what it is. I would be driving the trash too. I got a Tundra with 244,000 miles on it, but I'm not taking that car on vacation. I'm using it to move. It's full of palm branches right now. And I'm good with it. I like it. But if I'm looking to be like, hey, I need this car to get to work, and it's something old piece of junk like that, I'm probably going to break down on my way and then end up kind of flaky. And they're going to be like, hey, what's up with you? You can't show up on time. I'll be like, my truck, who would have saw it coming? It's 240 something thousand miles. And I thought it'd be perfectly reliable. Like, nobody thought that. That's insane. That's just not what you got. That's just the fact. Oh, I know. And that's gnarly. I mean, that's cool. That's awesome. But like, if you need to be reliable at your job, the 400,000 mile car is going to let you down someday. It might be good for a while, but someday it's going to let you down. And I would have seen it coming. It's just the way it is. Uh-huh.
You think the auto repair industry is still going to be that good, even though it's getting more expensive?
I do. And the reason why is because it's also getting more expensive? The cars. There's so much money. I mean, that's the problem is to be really honest, a lot of times people will come in and I'll say, you know what you should do? You should get a new car. And then that's when they tell me like, well, I can't because the credit and the income and the this and the that and the that. And I'm still saying like, if the car's got a couple 100,000 miles, my answer is still, you should get a new car. I'm not saying you can. I'm not saying you have the ability to. I'm not saying there's not 1,000 things in the way, but I'm just saying if you look at the options, that's probably going to be the cleaner one. If you had, let's say, $18,000, you could buy basically like a slightly used 2023 Corolla. And we're not even talking about fixing that car other than basic maintenance for the next 150,000 miles. It's hard to really argue with that. It's 18 grand and you're good to go. 150,000 miles could be the next, for the average driver, that's 10 years. 18 grand over 10 years is pretty low money. But they can't come up with the 18 grand, or they can't get the loan, or they can't get the whatever. Yeah, just fix the piece of crap. Whatever you got, fix it. Try to fix it efficiently. It's a lot cheaper to fix it right the first time than it is to replace this wrong part, to replace that wrong part, to replace the other wrong part. I'm just saying, like, you're replacing a lot of stuff and stressing about a lot of stuff when you can get a car that'll last you a lot of years for not that much money. Now, if you want a nice truck that's 70 grand, that's 70 grand's a lot more money, but there are fairly inexpensive cars that'll last you a long time. Now, don't make me a salesman, so let's move on. I'm just calling it how I see it, though. All right, so again, this right here, this was monitored through the scan tool. If you wanted to see it raw, this is actually probably the picoscope. Yeah, the ups and downs, ups and downs. Now, if it were me, we could adjust some of these time duration on the picoscope and spread it out so we can see it more carefully. But basically, these look the same. So we kind of know we got an issue there. Now, like another system, for example, these were considered, these a lot of times are continuous monitors. A continuous monitor like the misfire and some of these voltages and stuff, that's going to be something that runs like pretty much all the time. It's looking for misfires like all the time. Like when you get in and start it, it's checking for misfires. When you drive down the road, it's checking for misfires. When you sit at idle in the drive-through, it's checking for misfires. When we get in non-continuous, like the catalytic converter we were talking about, there's certain settings, the enabling criteria. So it's not checking your catalytic converter all the time. To check the cat, you may have to do these. You may have to drive on the freeway for a certain amount of time after a warm up and after these things, right? So when you see these terms, continuous and non-continuous, just know non-continuous only run when all the criteria is met. Okay, makes sense? So when we're looking at, for example, the evaporative emission system, this is a cause of many codes. What do you think the most basic cause of an evaporative emission system leak is? Gas cap. But see, the code didn't say gas cap. And I'm going to say that problem right there is one of the main reasons that people are really sketched out by automotive. Is like, hey, you got a check engine light on. In fact, I remember my sister got a 96 Civic. She's quite a bit older than me. And my dad was an automotive guy, but he's an auto body guy, collision, you know. So if you got a twisted fender, he'll make it straight, but he doesn't have this brain right here, right? So she got a car, 96 Civic. The check engine light came on. My mom said, will you take a look? He goes out there. He's like, yep, we're going to check the oil. He checks the oil. He's like, hey, you need to check your oil. Your oil was low. Put oil in it. And like, that's his brain, right? And did it fix the check engine light? No. But you see, like the common person, even if they like cars and they drive cars and work on cars, if they don't really understand this system, they won't really even know where to start. He didn't even know what a scan tool was back in those days. So instead, she brought it to the shop. The shop checked it, and it was a P0455, I believe. It depends on which, there's several different codes that could be set. So it was for a gross leak, a fuel evaporative emissions, large leak or gross leak. That means like the whole system is leaking. It won't even slightly hold any vacuum or pressure. Cool. So the technician's like, oh, yeah. Pops the little, you know, on the Civic, it's got the gas door. You got to release with the latch, opens it up. There is no gas cap. She left the gas cap at the gas station. That was a very basic, simple thing. And yet, you know, that shop charged a full diagnosis fee, right? So this is where it gets kind of irritating. It's like, man, the check engine light was on. You checked it for an evaporative emissions leak. You opened the fuel door, the gas cap was missing. Like, you're really going to charge me for that? And I could see both sides of it. On the more merciful side for the customer, it's more like, look, like this was dumb. I didn't spend that much time. Just give me like, you know, a half an hour or something. The problem is a half an hour at today's labor rate's still over $50, 50 to 75. I mean, the labor rate's $200 an hour. That's $100. And see, you look at like the technician or the mechanic working there, they got the car, they read the RO, they pulled it in, they got the scan tool, they checked the codes. Now they found the code. Then they pop the thing, the gas cap's off. And I'm like, oh, stinking stupid gas cap or whatever. Put a gas cap on it, closed it, cleared the code. They're supposed to do a little road test, go outside, park the car and be like, hey, it was your gas cap. And the customer's like, what? I'm not paying for you to put a gas cap on my car. But see, there was quite a few steps leading up to that. So while I'd love to be like, no, customer, it's all good, I got you. And I can, if I want, I can do whatever the heck I want. Nobody tell me what to do. But I do tend to give away a little bit more of my time than I can really afford to. And at the end of the day, if I work on several of those types of vehicles, I'm like, well, I didn't charge anything for that. I didn't charge anything for that. But I worked 8 hours and there was at least, you know, a half hour right there where I'm not going to charge for it. I'm not the one getting the $100+ to the $200 an hour. That's not me. As a technician, you know, we may be making 25 to, I mean, some are making 50, you know, but let's just make it a simple number. California double minimum wage, $33 an hour, right? So it's $33 an hour. Like, I at least got to get paid something for that amount of time. So if the technician is not going to give away their time, probably the shop is not going to give away the whole service, right? So it gets tricky. Now, on the other side of things, it's sort of like you could go after public education and say, everybody that graduates out of high school is probably going to own a car. So we should pull them in at least for a 4-week automotive class and tell them, if your check engine light comes on, get your butt out of the car and look at your stupid gas cap. And that way you don't have to pay this fee. But who the heck am I? I don't make the rules. I'm just saying, like, I have no issue if the customer finds it themselves and they tighten it. I don't really want their money. There's way too many broken cars and I got way too much stuff to do. I'm not trying to make money on I'm not really beating the bushes for more customers. I don't need it. Trust me. If you actually can fix cars, people are gonna be chasing you. I'm telling you, I'm gonna leave my phone on vibrate. That's why. But if it comes in and now you got to take somebody and put them on the job and the technician's got to do the steps A, B, C, D, and E, F, and G, it's kind of like you gotta have to pay. Or the shop could pay the technician but not charge the customer. That's not profitable for business. It's just not. It doesn't work for business. Make sense? So here's how this system really works, right? Because there's 20 different codes we could set. If you're looking at this system, you got gas in the tank. You know that if you left gas out here in like a bowl, it would be evaporating, right? So it could evaporate and go right out the gas cap and go into the atmosphere, and that's bad for the atmosphere. And it's going to be like a greenhouse gases, and it's going to affect not global warming, but now climate change, right? So they're like, no, don't let it vent. Make sense? So we put a gas cap on there and now it's sealed. Now you got a different problem. When it evaporates, it's going to build vapor. It's going to build pressure. You can't just let it sit there like a bomb. So we got to vent that into this vapor canister, which is rolled up sections of charcoal, and the charcoal is going to absorb the vapors and it's going to hold it like a lot more safely. Cool. Then when you start the car and you run it, you're burning gas, right? So as the gas is going down, don't you think that's going to like leave a vacuum, like a negative pressure in here? So we need to be able to vent air in through the vent solenoid to replace the gas that's being burned, that's being sucked up by this pump, right? So we need to vent air in, but we can't vent air out because it's got fuel vapor. We need to put in the vapor canister. Then when we're going down the road and it's like, hey, your vapor canister is pretty full, like let's empty it out. We're going to run this purge solenoid and that's going to empty out the vapor canister, and it's going to end up sending it through the purge solenoid and into the engine, and actually it's going to consume it. And then when it consumes it, it's going to be burnt. We're going to adjust our air fuel ratio to make it approximately stoichiometric. And then we're going to treat it with the catalytic converter and even it out and remove the hydrocarbons and stabilize the carbon dioxide. And it ends up burning pretty clean. Some of the stories that I've heard, which is not my actual facts, but I'm going to repeat it because it sounded legit. I think it is. A car that has all these emissions components working 100% from like a current model year will put out less emissions than if you were to literally just like spill a puddle of gas in the driveway the size of 1 cup. That gas evaporating in your driveway is more emissions, more pollution than the car actually puts out. They told me in like a month or a year or something. Ridiculous. So if all these systems are working, we have no evaporative emissions because the fuel is not evaporating out. It's being stored and burned, right? We have very little emissions out the tailpipe due to very effective catalytic converters and this fine tuning of the air fuel ratio. And how do we know the cat's not hollowed out? You know, because my dad's is. Now he's just talking about getting a smog. I'm like, dude, you're screwed. Like this isn't the backwoods anymore, man. You got to get a smog in California. You're not going to pass. I mean, you can't, what are you going to do? Well, they can't tell it's hollowed out. Well, let me remind you of something. It doesn't look hollowed out, but you know who knows it's hollowed out? Yeah, the O2 sensors report it, and the PCM's like, duh, like PO420. He's like, hey, I need a smog. And they're like, you got a PO420 set. This fails. And he's like, well, my son will clear it. And I'll be like, yeah, clear. And then they go in and like, oh, hey, your tests aren't ready. You got to go drive it. And he's like, oh. And then he goes and drives it through the correct cycle and it fails, right? So this system's on lockdown, really, is what it is. That's what they've done. The whole reason this monitor exists is to tell if the catalytic converter's hollowed out or defective because of oil consumption or, you know, et cetera. So, right, like with this system needs to be in good working order. They monitor it in several ways, but one of the ways they monitor it, we have a pressure sensor in here. And if you're going down the freeway and we close the vent solenoid, that means new air can't come in. And you don't purge it, that means no vapors coming out. And you run down the freeway, the fuel pump's sucking up gas, right? So that's gas levels going down. It wants to pull air in, but it can't. That's going to make a vacuum, like a suction, correct? Depending on how sealed the system is, it'll make a varying amount of suction. The vacuum, if it's really well sealed, that vacuum will be like a very deep negative pressure and the system will pass. But what if your sister forgot the gas cap at the gas station? It tries to seal it. Does it build any vacuum? No, because the gas cap's not on the car, it's at the gas station. So fresh air comes in, it's like, hey, we have a leak. How much of a leak? A large leak or a gross leak? Gross meaning like total. Like the whole system can't even get sucked into a vacuum. Bing, check engine light, right? So if I see that code, it's a gross leak, I'm going for like the gas cap's full on missing. But if I get a code where it's like P045042, small leak, it's going to be like, it's not a missing gas cap. It could be a tiny little leak in this hose. It could be a tiny little leak in that O-ring. It could be a pinhole on the top of the gas tank, or a little bit of dirt got on the seal in the fuel pump, on the fuel pump seal, right? So like sometimes when you go to find the leak, it's really hard to find. And we end up having to inject smoke in the system and look for a little bit of smoke with a really bright white flashlight. Like we get the code and it might be an easy fix or it might be a hard fix. That's probably why if you have a check engine light and it shows up at the shop, even if it's just the gas cap, they're going to bill you the full time. Because sometimes it's easy, and then other times it's like, man, I had to end up like pumping smoke in there and I had to lower the gas tank a little bit, and then I found it was this tiny little leak, and like it took me an hour and 15 minutes, but you know what? We're just going to bill for an hour, because sometimes we win and sometimes we lose. But when the customer calls and they say, hey, how much to fix my car? You got to be able to give them a price to do the diagnosis. So we can't be like, well, we have to diagnose it. And they're going to say, how much? You say, I don't know. It depends, right? We don't know. They're going to say, like, so it could be like $1 or like $1,000. I'm not dropping my car off with you. So they come up with a round, even charge, 1 hour diagnosis. If you can beat the hour diagnosis, good for you. But you won't every time, I guarantee it, because sometimes the diagnosis is a real sunny beach. Like it's a sunny, beautiful beach. Sometimes the diagnosis is very difficult. I'm going to tell you, right? So just without even going in crazy detail, this system's monitored non-continuously though. You got to have the right settings before they start to run those tests to see if the system is sealed. You know, and this one had the full drive cycle of how we drive and for how long and what we're looking for, right? And then like another one, if we have EGR, this one's an EGR valve. This canister was back here. EGR is different. So you're going to notice a lot of what we're going to do in this class is going to be not making, it's not just the basic engine stuff. It's a lot of emissions things, right? Evaporative emissions is a whole system to lower your emissions that's evaporating. EGR is exhaust gas recirculation. Without going into crazy detail, because we do, it's emissions controls. It's like the last thing we cover. But this valve right here, the system has to know if that valve is working or not. And there's two different ways they do it. This valve I like. This is my most familiar one, just mainly because of my age and when I was working on cars. This is more modern. This valve has 2 wires that run a motor to move it to open and close. Then it's got 3 wires that are a position sensor. Remember we looked at potentiometer? 3 wires are a position sensor to make sure that the valve is in the position that it thinks it's in, right? So if this valve sticks because of carbon, the way the ECM will know is because the position sensor will report it's at 50% when we told it to be at 100%. Make sense? So they put a sensor on the position, and the sensor is the tattletale to if the valve is stuck. Make sense? Also, they'll sometimes monitor mass airflow and these types of things. But if it's an older system, like this system right here, sometimes they use a temperature sensor. So this valve may use a temperature sensor. The whole purpose of the temperature sensor is to determine if the EGR valve is working or not, right? So if we open the exhaust gas recirculation valve, we should get exhaust gas recirculating. Is exhaust hot? So if it's correct, if it's actually recirculating, that temperature sensor should see what? Heat, exactly. But if the temperature sensor doesn't see heat, what's that tell the system? Yeah, like something's wrong. So it'll set some DTC for the EGR valve. Now, when a DTC sets, the check engine light comes on. Now, let me make sure you understand exactly why that's important to you. If you were in, let's not use Mexico. It's a little too close to home. It could offend some people. If you were in, well, the problem is I think Canada has pretty tight emission standards, so Canada won't work. If let's say you're in Brazil, I'm pretty confident, I'm not entirely confident. Venezuela? I think let's use Venezuela because I'm really confident in Venezuela. Venezuela is going to be like, oh yeah, emissions, don't care. Like literally 90% of the codes that set on our vehicles are all emissions related. Now there's some basic codes. A fuel injector, you need those. An ignition coil, you need those. They spray the gas, they light the gas on fire. Those things are important, right? But with a whole evaporative emission system, with a whole EGR system, with all this type of stuff, like that, honestly, you don't really need any of that. You can do what my dad did, hollow out the catalytic converter. Like that's like a little more like third world-ish, but if the car starts and it gets you from A to B and back, that's all some people are looking for. That's it. In fact, I'd be fine with that. But that's not where we are here. And even the whole US too. I mean, a lot of it's federal. So a lot of these systems are added to the vehicle to reduce a particular emissions. And then by the government rule, by law, legislation, these systems have to be monitored. So you can't be like, oh yeah, it's got an EGR system. And then you sell it to the customer and they're like, look at that piece of crap. Take it off of there, put a block off plate on that. How do I know about the block off plates? Don't ask too many questions. I'm just saying, if you unbolt this and you put a block off plate on, you're no longer having the low emissions that the vehicle was certified for and sold for, right? That the US is like, yes, you can sell that Camry because the emissions are at this standard. We love you, that you're the best. Sell those cars. Very good. And then everybody takes the emission stuff off and they're no longer at the standard. They're not going to let that fly. So they say, you need EGR, but you also need a system to monitor to make sure the EGR is working. And if the EGR is blocked off, you're going to get a code set for EGR performance because it doesn't see the increase in temperature, or it doesn't report back that the valve is moved because the valve is in the trash, or it doesn't report that your catalytic converter is being cleaned up like this because it's hollowed out like my dad's, who would look like this, right? So a lot of what these sensors are doing is reporting that the emission system is working the way it was supposed to, the way it was certified, the way it was sold in the federal government approved. And then you got California's the one of 50 who's like, well, there's the federal standards, but then we're a little bit higher. So like if it's a 49 state vehicle, that meets the federal, but then if it's a California specific, that meets California specific. But the thing is, lately they're doing 50 and it meets both, right? So if that system is defeated or deleted or removed or just straight defective, the system has to be able to identify that. So now here's the law summarized basically. if there's a problem with the system that's going to result in 1.5 times the emissions level, the check engine light has to be illuminated, a code has to be set, and it has to fail. All right, so if you had even, let's just say your catalytic converter back here was like, you know, not quite like this, but like not quite like this, like somewhere in between, they have a what's called a threshold. You ready to have your mind blown? A threshold. A threshold meaning if you're better than this number, you pass, and if you're lower than this number, you fail. And typically the threshold is going to be about 1.5 times the emissions level of perfect. So if your vehicle was 100% perfect condition, it's going to emit exactly what it's supposed to. We allow that catalytic converter or that EGR or that, not really so much with the evap, but a lot of these things to degrade slightly because we know they wear with time, just like us. When it hits 1.5 times the emissions level, boom, by federal mandate, that light has to come on, a code has to set, it has to fail. So a lot of the car is just to verify all these things are working at least 100 and, at least pretty well, better than 150% pollution level. Cool. Pretty nuts, huh? That's really what it's doing. Like a lot of these, your EGR right here, your so many things, even for example, like your thermostat, like when a car is really cold, we have to run really rich. That burns more hydrocarbons, that emits more hydrocarbons. That's bad. So we want to get the car warmed up as soon as possible. The way we do that is the thermostat. The thermostat is going to block the coolant flow until it's up to a certain temperature. Then it's going to open and allow coolant flow. And thermostats can fail sometimes. And if a thermostat sticks closed, the engine overheats horribly on the side of the freeway. You'll lock that engine up, blow a head gasket, seize it, crack a block, crack a head. Like thermostats failing are kind of scary. Nobody's ever had a thermostat fail? Oh, I bet some people have. Take it out. My dad took his out. You're going to notice a trend here. He did take his out. And, well, I no longer had heat in the winter time because the thermostat being out would make it so you don't have very good heat. But here, who cares? It's not that cold. Yeah, we monitor that. P0128, engine coolant below thermostat regulating temperature. If your thermostat's out, your PCM is looking at your coolant temperature sensor and watching how quickly it heats up. And if it doesn't heat up quick enough, boom, you get that code, P0128. Fail smog, you're polluting more than 1.5 times the emissions level it was certified for. Make sense? So again, I'm just going to keep telling you, so many of the things we do, so many of the codes we get, so many of the systems we have, it's not to make the car more reliable. It's not at all. It's to make the car emission standards what they were certified for. And who determined that? Some government person, probably multiple people say like, hey, the standard's right here. And the manufacturer's like, how the heck are we going to do that? And they're like, the standard's here. Like, I don't know how you're going to do it. I'm just telling you, you got to get here. You can't sell it. Bye. Bye-bye. And then you get the manufacturer. They're figuring stuff out. But then what do you as the technicians have to deal with? A new system, a different system, an increased system, a change system, of this system, of that thing, of that thing, of the other thing, of the other thing. Like when I first started, there wasn't even a code for the thermostat. They didn't even have that. And then they're like, hey, to meet the standards, we need to make sure that our thermostat is functioning properly. Makes sense? So if you like old school cars, Ronnie likes old school cars. You can pretty much do whatever the heck you want because if it's pre-1976 here, there were no standards. And if it's in most other states, they only really start looking at standards in 1996. So remember that number. That number is going to come back up when we look at OBD I, II. Exactly. Yes. So just so you all know. Now, I'm not really particularly bitter about it, mainly because, I do think that we should take care of the environment, just so you all know. And I think there's reasonable ways to do it. And I think some of the ways are a little over the top. But I think some of the ways are good. Like I don't have catalytic converters hollowed out on anything I own at all. I don't. In fact, I won't even get involved in that because honestly, most of the time I can fix the problem cheaper than people trying to hollow the stuff out and then paying for the Chuerco smog and all this type of stuff. Like, just, I'm out. Like, I'm not getting involved in that. But just so you guys all understand, like, the cost of repair is substantially higher as a result of these systems. And so for the common person, I don't think they really know, but if they knew, they'd probably be pretty mad and be like, forget this. We're going like straight India and China style. Like, we're going to light it on fire. We don't care what it emits. We're good. We're like, just let me keep most of my money and I'm happy. Make sense? Or, you could get an older car and do it the older way because you can get out from some of the standards, right? But part of the reason I don't totally knock it is, like, back in the day, technicians didn't really need to know that much about this stuff. So they were really more like mechanics, like straight up mechanics, make the car work and it's good enough. And that was fine, but I probably wouldn't have pursued this career if that was the case. This stuff, in a lot of ways I dislike it, but in some ways it benefits me. Knowing the more complex systems and being able to fix them is probably going to make you worth more money, right? So it is a love-hate, just so you know. As a consumer, you may hate it, but like as a professional, you may be like, no, this is good. I mean, we need to have a lot more skills, and so therefore we could bill a lot more money, because a lot of the people that don't have the skills, they really just can't do it. So it's supply and demand, basically. All right, cool. Different types of check engine lights. We can now call this the MIL. MIL standing for malfunction indicator lamp. The check engine light is fine. I'm good. But what the heck does that mean? Pop the hood and check your engine? That's what my dad did. He checked the oil, check the engine. But like, it more means malfunction indicator lamp. Like, there's a malfunction. What's the malfunction? I don't know. I have no idea. That's what I'm saying. People say, hey, I got a check engine light. What do you think it is? It's like, I don't freaking know. Exactly. It could be a million things. I don't know. So a MIL makes more sense. It's just got a malfunction. What's the malfunction? I don't know. Maybe it's one of these. P0001, the very first original code. Fuel volume regulator control circuit open. We don't even really have that code anymore. In fact, most of these codes we don't really have, but there is a number assigned for every code, right? So the manufacturer, if they had, let's just say, how about this one's a little bit more realistic. What do we have here? P0121 is basically saying the electronic throttle control, TPS number 1 and number 2, output signals difference. All right, so it's like, we did have really basic codes back here, but then we have so many codes, they ran out of numbers, literally. And this one's not that bad, because it's only all the way up to 121. There's codes now, P1AF. And you're like, F? Why F? They ran out of numbers. There's so many codes, they ran out of numbers. Then we've got codes that are informational codes. It'll be like P if it's powertrain, 300 is 3 digits, but then they needed more numbers, so they made it 5 digits. So like, that's what I'm saying. There's a lot of codes, a lot of potential DTCs. Cool, as we'll get into. So let's give an overall of what's happening with the codes here. Each one of these would mean it ran a test and it failed. How did it fail? Why did it fail? Why did it run? I don't know. They're all different, right? So this one gave us a really nice breakdown, and you might not be able to read it from the back row. So I'll read it and then I'll summarize. And this is not a really new car. It's a 2012 Sonata or Santa Fe with a V6. The electronic throttle control system is made up of the components: the throttle body, the throttle position sensor, which is TPS 1 and 2, the accelerator pedal position sensor, now known as APS, cool, 1 and 2. TPS 1 and 2 are sharing same source voltage and ground. The throttle valve opening control by throttle motor, which is controlled by ECM. All right, pause. What I'm telling you is, this is the drive-by-wire system. You push on the gas pedal, it's not pulling a cable. You're pushing on a gas pedal, the position is being determined by the accelerator pedal position sensor. Do you know how I know? I really don't need to read this. Do you know how I actually know this? A lot of studying. I've had a lot of problems with this. If I run into a system that's brand new that I don't know, I don't necessarily go back to the textbook, right? Everything I'm really trying to teach you in this class is the foundations, the fundamentals, and whatever. I told you, I think on the first day, the systems are constantly changing. You're going to be fixing stuff that I don't know about. I'm basically all I am is like a liaison for you. I get manufacturer information. I tend to understand it due to a little bit extra training and some experience, and then I try to teach it to you in a way that's a little more digestible. They're building stuff, they're experimenting with things in dark rooms. I've been in some facilities where you don't even know what the heck is happening in there. Toyota, for example, they have a place called the high bay. The reason it's a high bay is it has a garage door so big a tractor trailer can pull in. Why do you think a tractor trailer would pull in there? It has no windows, no skylights, no contact to the outside world at all. It's a big, beautiful building. I mean, don't make it, it's not a dungeon at all. It's huge, it's well lit, there's big fans, but it has no way you could see in. If they want to do experimental stuff, don't you think somebody might see it coming through the parking lot, getting inside? It's the high bay. It'll be in a contained trailer. They will pull it in the tractor trailer, close the door, no one can see inside, and then they'll unload it out of there. They're working on stuff I don't know about. In fact, when I went to go in there, they said, hey, no cell phones. And I was like, well, I'll keep my phone, but I won't take any pictures. But like they meant it. They were dead serious. Don't take any pictures because they cleared the area. They were pretty sure there was nothing secret, but like there's always the chance that they left something out. Why do you think they're so secretive? That's exactly what it is. They're trying to sell more cars, right? So if the government's saying, hey, you need to meet these new standards, and they're researching ways to meet the standards, they're not making money they make money by selling cars. So they're paying engineers and stuff to research R&D, find new ways, find different things, find different stuff. If, I mean, if Honda would give me a little bonus, maybe I'd take a couple pictures of the Toyota stuff. I'm like, hey, Honda, check this out. I could save them millions of dollars. They don't have to research and develop anything. They can pretty much see where Toyota's at and copy it and be like, yeah. They saved a bunch of money to get ready for the new standard, but they didn't have to research and develop it. That'd be pretty potentially profitable. So no, it's like they lock the stuff up. You don't even know what the heck they're doing. So my main focus for you is I'm going to try to show you the format of how to deal with the stuff that you haven't dealt with. When this system first came out, I didn't go back to the textbook because the textbook is more of an overview. I would go to this right here, this general description. This is going to be the go-to for you. If you don't know how the system works, you need access to that information, probably through subscription, and you're going to read about it, right? So like I was saying, when you push the accelerator pedal, an accelerator pedal position sensor reads it. And then it gives it to the PCM as an input. So if you push it halfway, what would that be in percentage? 50. But technically, your sensor doesn't read in percentage, right? Your sensor reads in voltage. So they're going to determine what voltage equals 50%, right? And then they're going to have two. They're going to do a redundancy. They're going to have APS1 and APS2, and they're both going to give different voltages. But if they both say 50%, the PCMs would be like, all right, cool. Accelerator pedal, they want 50%. They agree. However, after that, we're going to open the throttle with the motor, right? And you also notice that it said it has TPS 1 and 2. Okay, that's interesting. So when your throttle opens, it's going to have a sensor to verify your throttle opening is where it's supposed to be. And then it's going to add another one for safety. So your accelerator position sensor has to agree. And if it says 50, it sends a signal to the ECM, and the ECM's like, yeah, 50, and they agree we're good. Make the actual throttle open 50, and then verify it's at 50. And then verify it's at 50 with a secondary sensor. That's TPS1 and TPS2, throttle position sensor, right? So it's a double redundancy. Everything has to agree. So if you put your foot on the gas, then you let your foot, the accelerator pedal, sorry, If you let your foot off the accelerator pedal and it reads 0 and your throttle still reads 50, what's happening? The throttle's stuck open. That's like a big safety hazard. Boom, shut it down. Kill the spark, kill the fuel, kill everything. Like that car's not going to run away. No way, no how. Cool. Whereas if it's an old school cable and the cable sticks, you could be like, cable, please let go. You could try to pull on it or something, but like there's no override. Makes sense? So it is actually, I would say, more safe. Like we joked around last week after lecture, like, you know, people were on Oprah talking about how their car ran away and they have post-traumatic stress disorder and they need millions of dollars now to feel better. You know, like honestly, that system, I don't believe it failed. I genuinely, I don't believe it failed. I just don't think it did. This makes a lot of sense to me. If you had your accelerator pedal position sensors disagreeing, the system kills the throttle. If your throttle position sensors disagree, it kills the throttle. If your accelerator pedal and your throttle position sensor don't match, like a throttle stuck, it kills the throttle. If for any other reason it doesn't like something it sees, it kills the throttle. I don't understand how allegedly this throttle was doing whatever it wanted, however it wanted. I just don't buy it. I don't think so. Except, of course, the floor mats. Yeah. If the accelerator pedal was stuck under the floor mat, all the sensors would agree. Everybody's happy. It's just that the pedal's stuck because they got doubled up floor mats and a bunch of junk. Okay, I believe that. That's basically what this is saying. So if you were to read it, you might be a little confused. Sometimes you got to read it twice. So it's saying the throttle valve opening is controlled by the throttle motor, which is controlled by the ECM. The opposite position indicator shows inverted signal characteristics. If you got that, I'm impressed. Okay, I'll come back to that. TPS1 output voltage increases smoothly in proportion with the throttle valve opening angle after starting. TPS2 output voltage decreases the inverse proportion with the throttle valve opening angle after starting. TPS provides feedback to the ECM to control the throttle motor in order to control the throttle valve opening angle properly in response to the driving condition. Like, duh, you understood everything that said, right? I'm going to tell you, it takes some time and effort and practice to really be able to read this. This is not normal writing. Would you agree? This is like kind of hard to understand. They use a lot of terms, they use acronyms, and it honestly sounds like a computer wrote this, doesn't it? But this was written by an engineer. And engineers are smart, but they're different. They're different types of smart. Like an engineer knows every intricate detail of this system and then writes it so that a technician could read it. But see, your job is different than them. That engineer designs this system and knows every single aspect. Your job is going to be fix the stupid car. You need to diagnose and fix the car. You need to know enough to get in and diagnose and fix it. You don't necessarily need to know all the details of throttle, drive-by-wire electronic throttle systems, because guess what? The next car is coming in for tires, and the car after that is for the P0128, and the car after that needs an alignment, and the car after that set that P0420. So like, you don't get to just be an expert on throttle and be like just the throttle master. You got to know enough to fix it, but you got to know a lot of different things. You need to be like, you need this much depth, but it needs to be this broad. Whereas the engineer is like, I only do throttles, but I know every detail about the throttle. Makes sense? So like, this was kind of hard for me because I came through school and I'm like, we weren't learning about this when I went through school, for real. This wasn't really a thing. They were like, oh, they'll never do drive-by-wire. That's just crazy. Well, they did it. And they've been doing it a long time. This is a 2012. It's not even that new. All right, so I'm going to reword this in a way I think you guys will really understand. And I could even probably pull a picture that now that I think about it, would be a good idea. So accelerator pedal position 1 and 2 are going to go up at different rates. Okay, so right now I'm gonna cheat a little bit because I can pull up a graph. AP, it's usually APP 1 and 2 graph. All right, because I think visually, I don't care about AI. Stop it. AI, you suck. That would kind of work. I bet you this will find it better. All right, this is pretty excellent. Open image, a new tab. All right, it's actually really good. Full screen it. All right, you see VPA and VPA2. We could reword that as accelerator pedal 1 and accelerator pedal 2. If we have, I don't know, let's make this 50%, right? This one right here is 50% throttle. We'll call it by name. VPA2 should be around like 2.5 volts, or VPA should be around 2.5 volts. VPA2 should be like 3.1 volts, right? Does that make sense? As you accelerate, like let's say this is, let's see if that's 50, this would be like, I don't know, 20, 40, 60, whatever. Let's say this is 20%. We should have like 1.1 volts and like 1.9 volts. They have to agree. If you push the gas a little harder, we should have like 1.8 volts and maybe like 2.5 volts. If you push a little harder, we should have 2.3 volts and 3.1 volts. If you put, they have to agree all the time. Make sense? I would just explain that in a picture. So what if you had a failure on VPA and VPA was flatlined down here? Would they agree? Okay, I agree. If you were to get a code where VPA and VPA2 no longer agree, you know that you got a problem where one of these sensors is not agreeing with the other sensor. So if you look on this diagram, VPA is up here, VPA2 is down here. If you had an open wire on VPA, the ECU would not get the correct matching signal, right? It'd be like 0 volts on VPA and 2.5 volts on VPA2. That's going to set a code. The system's done. So if you've got this type of code, you really need to have an overview of how the system works, and then you could make a plan, right, to check, is it VPA, is it VPA2? You can use the scan tool. Some of the stuff we'll cover next time. We'll actually come back to this. This is a good one. All right. So those should go up in a graph. Now, this one's not that hard to understand, but actually the throttle, position, sensor, A and B graph is even nicer because those ones are inverse. So APP is typically going, they both go up, but they go up from a different voltage and they need to be a volt apart. Whereas this one, they're usually inverted. Let's see if I can find one inverted. Wow, there's all sorts of junk in here, but not the one I want. There you go, right there. In fact, you can probably see it pretty well. All right, if sensor 1 starts at 4.5 volts, at 50%, it should be around 2.5. At 90%, it should be around like 1 volt. Cool. Sensor 2 should start at 0.5 volt and go up to about 4.5 volts. So if you're at, let's say you're at 30%, sensor 1 should be around 2 volts. Sensor 2 should be around 3.2 volts. Okay, they have to be in agreement. All right, that's kind of what this is saying. Then the way that they word it, I mean, they're doing the best that they can, really. That's essentially what all this big old paragraph's about. Makes sense? So if you don't understand it, you really can't fix it. If you don't understand it based on this paragraph, sometimes you got to think about it. Like I have these long motorcycle rides, I'm thinking about stuff. And sometimes I think about it enough and it starts to make more sense. Other times I'll go to somebody who is, you know, also a technician, and iron sharpens iron. So I'll be like, hey, have you seen this? Have you heard about this? And they'll be like, yeah, it works like this. And then we could have a back and forth where at the end of the conversation, either I learned from them or maybe we both learned something from each other. So that's a big part of what we do, because when you get this code, it doesn't, you see this code was P0121. And that's really just for like a throttle mismatch. I don't even remember exactly what the description was, but it's not going to tell you exactly what to do or replace. What it's going to tell you is there was a mismatch and this is how the system works. So then it's up to you to get the diagram like what we looked at. It's saying that checking the output signals from TPS 1 and 2 under detecting if the output signals difference between TPS 1 and 2 are detected for more than 8% for the specified number of times, the ECM will set the code. So if the ECM set the code, there was a difference between TPS 1 and 2 of more than 8% a certain number of times. So now you know exactly why the code's set, how it's set. So this is telling you like the general description of the system. Cool. And then it can tell you possible causes like poor connection, open or short, faulty TPS, faulty ECM. So what do you want to replace? The harness, the throttle position sensor, or the ECM. It could be all of those. And then like last week I told you, sometimes it's a programming thing and you can't replace the programming. So like you got to actually know. If your whole plan is just to shotgun something, you're going to load up 3 bullets in there and be like, harness, a TPS, and ECM. That'll fix it. Customer, it's going to be $3,000. And they're going to be like, what? Like, what are you replacing? Everything that it could possibly be? Be like, oh, wow. Okay. So like you go to the doctor and the doctor's like, yep, we're just amputating it. We're just going to replace your whole body or something. Like that's scary. All right, so that's kind of what we're getting into. And then this is again showing you the specs. So if you were to do the checks, you could actually get some specs and be like, all right, at 50%, I should have 2.3 volts on TPS 1 and 2.7 on TPS 2. You may actually have to get your meter down there and actually check this to see if TPS 1 is reading right or if TPS 2 is reading right. And probably one of the two is not going to be reading right. Cool. And so overall, a little bit more about codes. There's type A. Those are emissions related. So is type B. Illuminates the mill on the first trip. You know what that means? The code sets, the check engine light comes on right away. Cool. Makes sense. Misfires. A lot of more major DTCs are going to be like that. It's going to store what's called it's going to store a history DTC and store a freeze frame information on the first trip if it's empty. So there's only so many freeze frames it can fail. If there's no other codes, it'll set a freeze frame. Anybody ever heard of the freeze frame? Freeze frame? No? All right. It's basically going to take a quick snapshot. The second that code sets, boom, it's going to take a snapshot at what the speed was, what the temperature was, what the runtime was, what some of the sensors are reading, right? So if I get a code and it's like, it's a code for a misfire, but maybe it's not happening right now. I want to know what was happening when the code set. And there are instances where I go in and it says vehicle speed 117 miles an hour, engine temperature 237, and I'm like, I drive it and it doesn't misfire, and then I go to the customer and be like, hey, I know you got a misfire code. The check engine light was on for a misfire, but I wasn't able to duplicate it. And they're like, well, yeah, you need to. I say, well, when it said it was at 117 miles an hour and your engine was overheating, you really want me to duplicate that? And they're like, how'd you know? And I'm like, it's stored in the freeze frame. So that's to help you as a technician duplicate it. Like sometimes the cars only do this symptom under certain conditions. The freeze frame records the conditions. So check the freeze frame out. You might be able to, get a better picture of what was happening when it failed. Like, for example, maybe the car only has a problem when it's really cold out, or maybe it only has it when it's really hot out. You could detect that in the freeze frame by looking at the ambient air temperature or sometimes the intake air temperature sensor. Cool. So there's a lot of information there. Or if it's a type B, it's emissions related. It's a pending code with the first time it's set. So that means like if it's a, let me think of a pending code. Probably, I mean, some of the circuit codes are like that. maybe, let's just say it's an evaporative emissions leak. That's a 2-trip. If your evaporative emissions leak test fails once, you don't get a check engine light. You'll get a pending code, but the customer doesn't see that. There's no mill. The technician could go in and check to see if there's a pending evaporative emissions leak, but it has to fail again for it to actually illuminate the mill. Sometimes for less important things, we might not have that mill come on the first time just because, you know, it'd be like, well, it failed once, but like it's not really a big deal. If it fails twice, then we'll actually make it a big deal. So just so you know, the part of the reason that this is so critical is if you look at the car and it doesn't have a mill, you could be like, well, it doesn't have any codes because there's no mill. Well, that's not true. If it's got a type B, it could have a pending, and you could go in and you could get that information where you might assume that it doesn't have it, right? If it's a type B. Cool. So you'd see it as pending. And then eventually, if it passes enough times, it'll go away. But it'll remain pending until a second time it fails, which will become current, or if it passes enough time, the pending will just be gone. It'll go to history, and then if it stays in history long enough, it'll be gone. Cool. But it takes like usually 40 trips to be gone, sometimes 80, right? And then a C is non-emissions related. Look at this. Does not cause the emissions to rise greater than 1.5 times the FTP standards. Okay, I previewed you with that. I actually forgot this was on here, so I thought I had to do it from memory, but now you can read it. Okay, what the heck is the FTP? Federal Test Procedure. So when the vehicle is sold as like a super ultra low emissions vehicle, they do a federal test procedure, and then they certify it. Yes, this is in fact a super ultra mega duper ultra low emissions vehicle, right? But if it's going to exceed 1.5 times that certification, boom, the mill has to be on. These codes do not cause the emissions to rise greater than 1.5 times the FTP standards. So they don't illuminate the mill. It may request illumination of the service lamp on the driver's information center. Sometimes they can be, it's a first trip. It could store a history DTC. So let's say maybe this is a failure of a sensor that doesn't relate to emissions, which it's kind of dumb because honestly, if it doesn't relate to emissions, then why'd they put the sensor on there? But let's make one up and just say this is a, it's a tough one. That's a tough one. How about a ignition feedback sensor to tell whether there was thorough ionization during the combustion burn? Something stupid. Something like some manufacturers will add an extra sense to tell if the combustion was really thorough, but it's not necessarily tied to emissions and it's not necessarily required. It's like a system that they went above and beyond on. Sometimes the Germans will do something like that because they'll be working with Bosch and be like, hey, we're going to roll out this new system. It's really awesome. But then it's kind of like, yeah, but you didn't need to. So why do it? And they're like, well, we want to be on the cutting edge of technology. And then it'd be like, cool. Now you know why that car costs so much more money and why when it breaks, no one knows what to even do with it because they wanted to do it, right? That would actually be like a type C DTC where like it's there, but it doesn't necessarily illuminate a mill. Why would you even care about that? Maybe if the car has a symptom and you're struggling to diagnose it, you might want to know, hey, it did set this code. Maybe that code for an incomplete combustion burn could be related to an actual misfire, but it's otherwise kind of hidden, right? And then D, again, non-emissions related, does not cause emissions to rise greater than, does not request illumination of any lamps at all. This would be an example of maybe like a lost communication between two modules that aren't critical. You'll go in and you'll be like, there's no lights on, there must be nothing wrong. And then you'll actually run codes and you'll be like, hey, there's codes in here that like don't even turn lights on. That could be a type D. doesn't set any code, or it doesn't make any lights come on, doesn't make any things do that, but it's there again for you to know that there was some sort of an issue at some point that they deemed not really critical, but it could help with your diagnosis. Make sense? So for the most part, cars don't come in for type C and type D, but if they come in for a concern and we're struggling to figure it out, you might check to see if there's any type C and type D, right? But they're just hidden. You got to dig them out. Kind of sort of makes sense. And then when we look at pending, remember pending is a 2-trip. So that could be a major problem, but it hasn't failed twice. So you might be like, I don't think this car actually has an issue with a torque converter clutch, but it kind of felt like it might, but there's no code. Well, let me see if there's no codes. There's no check engine light. You plug in, you're like, oh, it's got a pending torque converter clutch lockup solenoid issue. And you're like, oh yeah, that kind of confirms like it's about to set the code, like you're on the right track type of thing. But what if it happens if you do 40 to 80 warm-up cycles, it'll actually just, it'll be gone. And then you'll never know it was there. Cool. So that's how it really works. And overall, I think that's fairly straightforward on those. This one's way different. All right. So on these old codes, you could either clear them or you could drive them enough for 40 to 80 warm-up cycles. That may be like a month or two, or sometimes more, to go away. But this is what was happening. People would come in and they'd be like, hey, I've got this problem. They'd bring it to the mechanic. The mechanic's like, oh yeah, you need this part, and pay us a bunch of money, and it's your check engine light that's on, and when you pay us the money, your check engine light will be off, right? So they would take their money. They might replace something, or they might not replace anything, but you know what they would do? Clear the code. Customer comes to pick up the car. They start the car. There's no code set. And they're like, oh yeah, I'm so happy. Here's your money. And then they leave. And then guess what happens? It comes back. Why wasn't the code on right then and there? They cleared it, and it was probably a non-continuous monitor. It might have even been a 2-trip, like a type B. It may take specific conditions and time and miles and enabling criteria and a cold start and whatever for it to come back, okay? So the customer just kind of got ripped off, but also, wouldn't you say, like, the car put out more emissions because it didn't get fixed right the first time? So the government rolls out and they're like, hey, EPA, permanent DTCs. If it sets this DTC, you can't clear it. I can't clear it. No scan tool can clear it. Disconnecting the battery won't clear it, right? So you guys know if you want to clear codes, you clear them. Technically, though, if you wanted, you could disconnect the battery and leave it disconnected for a while, and it'll probably clear it. But it'll also erase all your monitors, and they'll all go to incomplete. It's kind of similar to clearing codes. It's just, it also resets some other things, and so that's not the right way to do it. Other people will disconnect them, make sure they're not connected to the battery, touch them together. That'll help discharge capacitors, and it'll lose its memory quicker. But with this one, none of that will work. None of that will work at all. And the check engine light will remain on. So you try to take the customer's money, and they come and they start it and like, hey, the mill's still on. I'm not paying you. Makes sense? So see how it's kind of to protect the consumer, but it's also kind of to ensure that we fix this problem sooner. How do you actually get this code to clear? Well, this is shown in the diagram. It failed. When you go to clear the code, it won't work. To get the code to clear, you actually have to have the monitor run and pass. So let's say it was a misfire. The car comes in, it has a misfire code. You throw spark plugs at it. You try to clear it. It won't clear because it's permanent. You drive it around. It won't clear because it's still failing the monitor. You didn't fix it. You're stuck with it now. Call the customer back. Hey, I was a ding dong. I didn't really know what I was doing. I threw spark plugs at it, didn't fix it. And they're gonna be like, well, I'm not going to pay you. And you'd be like, but I gave it to like my master tech. My master tech understood this, did the diagnosis, found out that it's actually got low compression in cylinder number 2. It's going to be a ton of money to fix the engine. Do you want to do it? And they're like, yeah, let's fix it. Master technician rebuilds the engine, replaces the engine, whatever. Puts it back in, goes to drive it. If the misfire is fixed, guess what happens with that monitor? Not the mill, the actual monitor, the test. If it's fixed and it runs the test now, what's going to happen? It's going to pass. When it passes, the mill goes off. You have to actually fix it, and you have to actually get it to run the monitor, and the monitor passing will turn off the mill. This makes a lot of sense to me, actually. I have no issue with this. This is a lot of technicians are like, oh, permanent codes, I hate these. And it's sort of like, why? I mean, the only reason you hate them is because you like the clear button and you make you feel better if you can clear it. But like, honestly, if it's fixed and you drive it and it runs the monitor and it passes, the light turns itself off, and then you're totally sure that it fixed it. Like I kind of like them in a way. But a lot of people don't. So everybody kind of clear on the permanent. It's not to say that it can never go away. It just can't be cleared. You have to fix it and then get the test to pass. The monitor needs to pass. Then it goes away. And I like that. And then, for example, like here's a freeze frame. You can just see it shows some info. It's a little hard to read, but when this code's set, the throttle, the RPM was 952. The throttle was 11.4. It could tell you what, any number of sensors will be recorded, but you'd go into freeze frame and you could see this. That's when you see, if it's at 117 miles an hour, you'd be like, oh, gotcha. We better talk about this. That car's, we're not going to be able to duplicate that concern. You can't go speeding 117 miles an hour and get pulled over and be like, well, I had to duplicate the customer concern. That's not going to get you out of that ticket. Again, don't ask me too many questions on how I know. I had to do it, right? And so that's kind of like giving you the freeze frame info, telling you what was up, what was going on at that point. Maybe, for example, how about what your engine RPM was, like we were talking about, or throttle position, vehicle speed. That's the tattletale. Vehicle speed at time of misfire, it'll tell you in miles per hour when that code's set. That's kind of scary. Cool. So then again, when we go to check for codes, you're just going to hit DTC display. Some of this rolls into what we're going to be doing next week. But you can also look at what codes what tests have not run. So let's say you had a car that came in for that P0128 and you think you diagnose it as a thermostat, you put a thermostat in it, you go do a quick road test, you want to know if it's passed or failed. You can go in there, not run since code cleared, and you can see if the P0128 has not run since the code is cleared, do you know if it's fixed? It hasn't run yet. Right? So you can go in there to see if the code is run. Now, once you go in there and P0128 is not on the list of codes that have not run, that means it ran. And if the code didn't reset, that means it passed. Right? That's a way to verify that the test actually ran and passed. Okay. You didn't think that the onboard diagnostic system would be this complex.
So if it didn't pass,
it would set an active code.
It would show,
boom.
No matter how long ago it happened.
So it runs that test. Let's just say for a P0128, it's probably going to run it every morning because it starts with a cold start. It may not run it in the afternoon unless your car was sitting a long time. But if it runs it every morning and it fails, and then you put a thermostat in it and you don't do anything, it will stay active until maybe like 40 cycles or some number of cycles, whatever's written. But if it comes into the shop, we're trying to tell if it's fixed right away. We replace the thermostat, we put the coolant in, bleed the coolant, we start it up, and be like, all right, clear the code, and then I'm going to drive it, and then I'm going to look at the code that has not run since cleared. P0128's there. Look again, it's there. Look again, it's there. Boom, if it's gone, then I can go into active codes, and if P0128's inactive, that means it failed. That means it's still bad. But if it's not set currently, and it's not on the list of not run yet, that means it passed. Right? So you can kind of like, again, this OBD II system is really about making sure you got the car fixed. And so you can use all of its features to make sure you got the car fixed. Sometimes it could be extra time consuming. It's time consuming enough just to discuss all the things it could do. Right? And so like, again, these are some codes that are set. If you wanted to know about what was happening, oh, this is a good one. That would be like probably at least a type C. Would be AC compressor clutch relay circuit. That doesn't affect emissions. So that's not going to be an A or B. That probably won't even cause a mill at all. That's a good one. But if you wanted to know more about it, you could click on that. You could go in and you can see, has it failed this ignition? And you could see, oh, yep, it failed this ignition. It's still broken, right? So there's some different tools you could do that are pretty good. Now with codes, we talk a lot about P codes. You know, we talk about the P0420, the P0121, the 128, the P whatever. Those are powertrain codes. Now you understand why they like to call it a PCM. It's a powertrain. That means engine or transmission. If you got transmission issues, it's setting P codes. If you got engine related issues, it's setting P codes. If you got emissions related issues, that's all P codes. That's all powertrain. That's all what those are setting. What if you have an issue with the headlight relay and it sets a code? That's not powertrain. Headlights, that's not part of your engine or transmission. Yeah, that's going to be body. Body would be like mirrors, lights, wipers. It can, but brake lights themselves are body, but the brake light switch is an input to the chassis because the chassis needs to know if you're pressing on the brakes for the ABS to work. So a C code being chassis is more like brake suspension. If you've got air ride and it's got an issue, it's setting a C. Correct. Bingo. So actually you got a good example. We focus, this class is mostly about powertrain, all right? However, because this is DTCs and onboard, the body has its own onboard. The chassis has its own onboard. We have onboard diagnostic systems running more than powertrain. When OBD and OBD II first came out, they were like, hey, you only need to monitor the powertrain. Like, we don't care about the rest because that's not emissions related. We don't, if I could give you a couple quotes. If someone from the government comes and bangs on your door and they say they're here to help, I don't think so. Okay. So again, I'd say if the government's all about safety, why didn't the government mandate body codes to make sure your brake lights are working and keep you from getting rear-ended at night? They didn't. You know what they did? They made powertrain to make sure your emissions levels are correct. And in the meantime, you don't have any brake lights and your brake pedal position sensor, your brake pedal switches, you threw it out and it's not monitored and we don't care. Make sense? Uh-huh. All right. So just saying. But however, later they were sort of like, you know what? This OBD II system's kind of good. Like if the manufacturer wants to, they can put a whole OBD system on your body, not your body, but your car's body, monitor all your lights, monitor your switches, monitor your windows. And now they do. Like for 20 years, cars have had body control modules and ABS control modules, and they all work the same. They all have monitors, they have tests, they set codes, they have freeze frame, you can look at live data, but we mostly focus on powertrain. And then if you have two computers not communicating, those are U codes. So if you have U, X, Y, and Z, that means that your communication network has an issue. I don't. We've gotten a little closer, but the problem comes down to really, if it knows it's in the circuit, it has no way to know where in the circuit. It already knows it's in the circuit. It already knows that there's an issue, but like, for example, if it was, let's say, a misfire, right? It can tell that it's not speeding the engine up, but there's no sensor to measure compression. There's no camera to look at fuel spray. There's no meter to measure your power of your spark, right? I'm not going to say they couldn't do those things, but then you look at cost, right? Then it's like, well, we need to install 3 or 4 different systems to tell you whether it's fuel, spark, or compression. Whereas like, they're good. It's a misfire. The technician will figure the rest out. I don't think so. I don't. But you never know. I could be totally wrong. I just think right now people are at the limit of what they're going to pay for a new car. And if you want to add even more sensors so that the technician doesn't have to diagnose it, I just think you're going to make the car too expensive. And then, yeah, your technician will have an easy job, but I don't think the cars are going to sell. I just don't think so. I think honestly, if a manufacturer could find a way to like get rid of half the sensors and half the computers and make the car $9,000 for a brand new car, they'd sell so many of those cars, but they can't because they don't meet the emission standards if they don't have this stuff. See what I mean? So yeah, pretty good. And then you guys pretty good with it's just communication. It's not Wi-Fi. It's like Ethernet in some cases, LAN, CAN, just communication type issues. We'll focus mostly on P. A radio could be a body code, but if the radio is not communicating, it could be a U code, communication or network code. Yeah, radios do set codes. Absolutely. Okay, then if we get into like, you know, how do you interpret it? It's a P, right? So what system is that? Yeah, powertrain, engine, good. The second digit is a 0. If it's a 0, that means it's generic. That means by SAE, Society of Automotive Engineers, it's a generic code. If this one was a 1, that would mean it's manufacturer specific. So some manufacturers have codes that other manufacturers don't recognize. If it's manufacturer specific, it's going to start with a P1. But this is a 0, so it's universal. Then the next one, third digit, is a type of ignition system problem, generally. So third is kind of already, you know, giving us some breakdown. So if this was P0300, that would be a random or multiple cylinder misfire. But if you notice, the 01 is actually telling us we're identifying the cylinder number 1. So this is a misfire, powertrain, generic, ignition related. We think it could technically be other things, but it's a misfire and it's on cylinder number 1. So which cylinder are we worried about? Cylinder 1, it says so right there, P0301, right? So if somebody's talking with me and they say, oh, I have a P0303, I'm like, all right, so what's up with cylinder 3? And they're like, dude, how did you know? And I'm like, there's a format, like it's not a big deal, man. It's a misfire, P0300 is the base number. And then you said 303, so that would be cylinder number 3. You know what I mean? There's a logic to this. It's not just random numbers and letters and stuff. All right, cool. So if you have a V8, you could have P03, 1, 2, 3, 4, 5, 6, 7, or 8. But if you have a 4-cylinder, it's P0, 3, 0, 1, 2, 3, or 4, right? So they do suck up a lot of numbers with just misfires because you have multiple cylinders. Similar with like ignition coil codes or injector codes, right? Now let's say you want to diagnose this, and this is going to be a little bit of an overview as to how we come about the diagnosis ourselves, but this is being combined with the onboard diagnosis system, which is a lot of stuff, right? Here we go. Car comes in. Most likely, we're going to, I mean, there's a number of ways you go about this, but some things to at least consider. You're going to scan it. You know what that means? Check codes. Check the codes. See what we got. Cool. You're going to probably operate the vehicle in the failure parameters. Say, what? What's that mean? We're going to drive it, but how are we going to drive it? How do you know that? Yes, you don't go to the customer and be like, what were you doing when this happened? And they'll be like, whoa, what do you mean? Like, am I in trouble? Be like, don't even talk with them. Get the freeze frame, see what was happening when it's set, right? So check the codes, see like, and honestly, if it's a misfire, if it's a P0301 and I go and start the car and I see the engine shaking, I'm pulling it right straight in. I'm like, look, it's happening right now. We're good. I like when problems are active and they're apparent. The problem is it's got a P0301 and then I run it. It's like, hey, it's looking pretty good. Like, I don't really see an issue. I'm actually going to be posting a video on Monday or Tuesday of a misfire that you guys might be interested in. This is a student who's saying, hey, I got a misfire code. And I'm like, what's the code? And I think it was P0302 and 303. And I'm like, all right, so cylinder 2 and 3, that's interesting. They're both misfiring and they're next to each other, but okay. I looked on the forums. I tried spark plugs. I tried this. I tried, can I switch injectors? And I'm sort of like, well, it's an engine class. If you want to switch injectors, sure. But like, why are you on injector so much? And so I kind of like moved him off of where he was trying to go based on what he read on the forums, and got to the point where he did another test, and I'm not going to tell you the name because I want to send you the video so you can understand where I'm at. I convinced him to do this other diagnostic test, and he found a major failure that explains the whole thing, right? So like sometimes when it's happening, you know, you got all these different potential tests you could do, but like, you know, right here, you only really need to operate it in the failure parameters if it's not doing it. If it's already broken and you can tell it's acting up, now I'm pulling that sucker straight in and I'm gonna figure it out right then and there. I don't need to go drive it a lot because it's misfiring right now, like his was, and I saw it. And there was white smoke coming out the tailpipe, and I mean, there were some clues. Okay, there were definitely clues, but he confirmed it, and I'll have it on video too. I just forgot my camera, my correct camera for this particular job. So when I bring the camera on, in fact, I don't want to let you down. So I need to set myself a reminder right now because this is a special camera that I didn't have. I need to get this camera in my bag for Monday real quick. Let's say Sunday. I'm just going to get cam. I lost 20 minutes of audio. Total bummer. Yeah, but I'll voice over it. That's what happens. All right, cool. Now don't worry, we're going to keep it rolling. If no DTCs are activated, check the basic engine operation, the engine condition, fuel, and spark. Generally, this isn't what we're going to do. Most of the time, we're doing diagnosis with DTCs. But if the car comes in, it has a problem, and there's no codes, sometimes we need to resort to basics. Okay, makes sense? If it's loss of power, we might go ahead and check for misfires in other ways. We might go ahead and check for fuel pressure. We might go ahead and inspect the spark plugs, etc. If it's operational, use the PIDs to identify the dysfunctional item. What? A PID? Boom. Parameter identification. So if I say PID, you guys should just know parameter ID is where you go in the scan tool, you go on live data, and it will show you what the sensors are reading currently. Okay. So for example, if we had a car and it had like a really clogged fuel filter, or the fuel pump couldn't make enough volume, it wouldn't have enough fuel. It'd probably run lean. The way I would know it's running lean is I would look at the PIDs and the fuel trim would be really positive, which would mean it's trying to throw more fuel to make up for something. So I would go in live data and look at the sensor readings and be like, does anything look out of line? But how do you know what's out of line? You got to really know how the stuff works, and you got to know what's a good reading and what's a bad reading. And you know, if it's a loss of power, like I hit the gas and it's kind of like, whoa, but it doesn't really go, I'm kind of like, hey, maybe it's starving for fuel. And I would look at the fuel trim PID, and that would tell me a lot. Okay. You don't really have to know everything about that yet. We're doing an overview on how you would proceed with diagnosis. Remember, this is OBD II. The scan tool has PIDs. What a PID looks like. Remember when we were looking at these? These are PIDs. DPFE sensor, or how about vehicle speed at the time of misfire? This is a PID, but that would be a recording of a PID because it's on the freeze frame. If you want to see what the PID is right now, you go under live data, and live data will show you exactly what the PID is right now. So you could do like an overall overview, but additionally, of course, we would have to gather info. What's the customer concern in this case? Probably the mill. That'd be a common one for engine. The mill is on. What do you do? Again, gather some information, maybe check for codes first, maybe test drive it first or road test it first. I don't know, could go either way. We road test it. If the mill is on, yeah, I don't know that I really need to road test it much more. Let's get back to the shop and let's go ahead and maybe do a simple visual, but to be honest, I'd probably do this first. I'd check it for codes because like, if I'm doing a visual, I kind of want to know approximately what I'm looking for, but there's nothing wrong with doing a visual first. Like if you see something majorly wrong, that'd be good to know. I do it a little bit different. I'm checking for codes first. Yeah, exactly. I mean, you still do need to do a visual though, because you know, if you get really focused on the code, but then you don't notice that there's like a big mouse nest under the hood, like, you know, you kind of need to do both. But like for me personally, I like to just get in there, like I want to know what the code is before I go too far. But technically, there's nothing wrong with doing your visual first. And if you find something is wrong, you need to let them know. So it does make sense to do the visual soon, early on anyway. Check for codes. And on a newer vehicle, I would do a full-on health check, which is going to check for codes in all the modules, P codes, C codes, U codes, B codes. I want to know everything. Because if I've got a whole bunch of issues, sometimes I get an image of like, oh, this has like multiple failures on multiple systems. That'd be maybe relevant information for me, right? And then let's say we could do, like if we do the whole check, it's going to check all the modules, even the amplifier or even the radio and stuff. So it's a good idea to do that to get a good picture. But like once I've done that and I'm looking back at powertrain codes later, I wouldn't do this test again because this could take like minutes, like not a minute, like it might be 5 minutes. 5 minutes doesn't sound long to you, but when you're trying to get paid and get it diagnosed, and you don't want to sit there and let this test run every time you go to recheck for codes if all you're worried about is the engine, right? So I might jump into just engine directly after I've run this one time just to save some time, right? And then, for example, we could look at the freeze frame. So this is giving us the freeze frame. When that code's set, it was, the code, by the way, is a P0353 ignition coil C primary secondary circuit. When it's set, the engine RPM was 952, throttle was 11%. Gives us a little bit of information. Honestly, that's a circuit code, so I think that we could probably figure that one out without having to drive it too much. We could probably start checking the circuit. Sometimes, how do you know that this code's currently happening? Like maybe it was a fluke. You think sometimes it's kind of a fluke? Like it might just be like a one-time thing. If you decide you do want to clear this, you need to record it. You could write it down, or on a lot of scan tools, you can save it as a picture, or in other ones, you can save this as a file. A file you can access later, okay? Because once you clear it, it's gone. You understand? So if you thought you were going to help me out when you're like, hey, I got to check engine light, I'd be like, okay, cool. What was the code? Well, it was something about a throttle position sensor, but I cleared it. I'll be like, you went on the crime scene and you just literally brought in your mop bucket and mopped it up. And now you want me to tell you what happened? Don't clear it unless you have it really well recorded. Then you could clear it and drive it and see if it comes back. Sometimes I don't do that step. Sometimes I'm sort of like, look, I know it's broken. I don't really want to clear it and see if it comes back. You know what I would do sometimes though? If I go and the car's got like a whole bunch of codes, low voltage codes and this code and that code, and if I'm like, man, there's too many codes here, I don't really know where to start. Sometimes I will clear it to see what comes back, and I'd maybe start with those to help simplify the problem, right? You never want to start with like a really big, overwhelming problem and just get yourself confused. So sometimes I will. For example, who's ever been to the drive-in movie theater? I don't do that anymore, but I know some people have. No, they don't do that anymore. All right, but back in the day, when you wanted to hear the sound of the movie, you'd have to leave your radio on, right? But the problem is, like if you're like me, if the first movie was pretty good and then you kind of fell asleep and next thing you know, you wake up like 2 hours later at the end of the second movie, your battery's going to be dead. I'm just letting you know. Okay, so if your battery was slowly dying, a lot of times your voltage going down can set a lot of codes that aren't really codes. Like, so if a car comes in with a whole bunch of weird codes, it might not exactly be because the drive-in, but like sometimes their battery was dying and it sets random codes. I might clear all that out, see what comes back. But I would record it first though. Okay, that's kind of the lesson, right? And then of course you're going to go into service info. Remember how we check for TSBs? You can't diagnose something from scratch and get paid for it if there's a TSB explaining literally what to do already. You even learned how TSBs are made, didn't you? Okay, so check TSBs. Probably going to have to pull some sort of information. A lot of times I'm familiar with the code because I've seen it before, but if it's a code like that last one with the throttle position sensor disagreement, remember that one? If you don't exactly know, This is where you're going to learn. You're going to read about the code, read about how it runs, read about the system, read about the enabling criteria, read about all that. You have to understand it before you can fix it, right? So some of that comes with all data, TSBs, researching. Generally, this is not going to be Google, though I'll have to admit, even myself, sometimes I'll go ahead and like, I'll Google it. And once in a while, I'll get a really compelling video or a story saying, hey, I got this code and I did this and I did that and I did the other thing. 90% of the time, those people are ding dongs. And I'm just like, nope. But I can tell the difference. Just listen to the terminology. If they're calling things by the wrong name, if I can tell they're kind of like fibbing the story to try to get clicks and views and stuff, I'm like, nope, right? But once in a while, okay, once in a while, somebody has had the exact same issue and they can run through the diagnosis that they did, I'll absolutely consider that information. Okay. Don't tell anybody I said that because that's not what's in the book. I'm just saying, like, YouTube has got some good stuff. Sometimes the internet has some good stuff. It's a little shameful, but once in a while I will read it. Most of the time, though, it's totally garbage, just garbage. But if I don't understand the problem, I need to get the information somehow. And even though I've studied a lot and been around a long time, I don't understand every issue. Okay, so you know, there's new problems for me all the time that I've never seen. And actually, I just remembered I'm supposed to look into a guy's problem on his Mercedes Sprinter van that's got a diesel and he needs allegedly his own diagnosis and knock sensor. But he said when you put the knock sensor in, you have to program the ECU and only the Mercedes dealer can do it. Like that didn't sound right. I really don't know. So I'm going to do this and read. And I have to remember that too, because I just don't know. All right. And then again, if it's determined that the TSB doesn't apply, then you would go with more research, come up with some information, some specs and some details. And then right here, this is something that you'd come up with all data. Okay. So it depends on the exact issue, but let's say that it's a code P0300. A lot of times when you put that in, it'll give you what's called a flow chart. Has anybody ever seen a flow chart? This is a flow chart. It's just one that you can't see all that well. It's going to be like, do this, is the result this or that? If it's this, go that way. If it's that, go that way. All right, so I'll walk you through a flow chart. DTC is P0301, misfire on cylinder 1. Fair? It might say like step 1, do a visual, step 2, you know, clear the code, see if it comes back or whatever. So let's skip to the meat and potatoes. It may say perform spark test. Is there spark? Yes or no? What do you do? Perform the spark test. If there's spark, is it yes or no? Is there spark? Yes. Boom. So then it would say like, if there's spark, yes. Proceed to perform compression test. But if you perform spark test and is there spark? No. No takes you to troubleshoot the ignition system, right? If there's no spark, the problem's in the ignition system. If there is spark, the problem's not to do with spark, right? So we might move on to compression. So let's just say, is there spark? Yes, we go on to compression. Next step, perform compression test. Is the compression within spec? Yes or no? What do? Perform the stupid compression test. Was it in spec? Let's say no. Yes would be probably perform fuel test or something. No would be, what do you think based on several weeks ago? If the compression test failed, what do you think we might do next?
Wet test.
Perform wet test. Did the number jump up a lot? Yes or no? If it jumped up a lot, we're thinking bottom end piston rings. If it didn't jump up a lot, what do you think it would say? Probably in the head, but how could we confirm it? Cylinder leakage. Perform cylinder leakage test, right? So these flow charts kind of walk you through the diagnosis, right? But to be honest, as a real professional technician, you should already kind of know what the flow chart's going to have you do, but it's good to follow the flow chart. You follow the flow chart, perform this, yes or no, do this, in spec or out of spec, do this. Was the result good or bad, right? It will guide you through it. Where do those flow charts come from? You guys know? Engineers generally write them, and the manufacturer publishes them, and then the manufacturer sells them to All Data or whatever. If you want to really be able to troubleshoot, you really need the information. If you don't have the information, honestly, it's so hard to fix anything. So like on my own with no manufacturer service information, no All Data, no nothing, like I'm kind of guessing and I'm kind of Googling. If you're a technician in a role as a technician, you need to have access to this. If the shop says, oh, no, we don't do All Data, that's like $700 a year, we don't have the money for that, you're not in the right shop. Like that isn't it. That's Billy Bob's bait, tackle, and auto repair. Like I get it. I've been there. But no, that's just not really going to work. Makes sense? If you're in the dealership, do you know what service information you get? The OEM, right from the manufacturer. You got all the info. So one thing I'd like to make sure you guys understand is you don't have to know everything. I don't know nearly everything, not even close. I have a lot of experience, so sometimes I can rattle it off like I remember it, but like nobody coming into the business has to be able to do that. You really have to be able to source the information, get on the flow chart, do the test. If you've never done a compression test, you're probably not going to be able to diagnose that car. But if you've done a compression test, you can do the compression test. You can interpret if it was good or bad. This will give you your next steps. And then you'll get to the bottom and it'll be like, you know, after your leakage test, did air come out of the intake or the exhaust or the radiator or the whatever? And you'd be like, yeah, air came out of the radiator. And it would say like, most likely it's a blown head gasket, but also check the head. That's how this troubleshooting works. It gives you the steps. You just need to know a little bit of basics and be able to perform every test it wants you to perform. And then you can fix the piece of junk. See where I'm at? They're all trash. All right, cool. And then guess what? You're going to do the repair, right? You do the repair. Maybe that last one was a head gasket. Cool. And you go ahead, you tear it down and you have the head checked by the machine shop. You put a head gasket in, you torque things to spec. How do you know how to actually do the repair and where do you get the specs? Yeah, we're going to, again, service information's guiding you. You're never just doing it from your mind. You shouldn't be anyway. You'd be following the steps, execute the repair. Then after you're done, you're going to write it all up, document it, document what you did, how you did it, etc. And then verify that the code is fixed, verify the misfire is gone, verify the mill is out, verify everything is good. And then you issue it back to the customer. That's how you fix it. It's not really rocket science, actually. But what if there's no codes? This was all based on you have a code. If there's no codes, guess what? You don't always get the flow chart, right? Gather information, road test it, perform a visual. Ooh, that all sounded the same. You check codes, no codes. Now you're like, crap. I don't like this one as much. If I have a code, I really know which direction to go into. If I have no code, this is a much more challenging, much more advanced problem. So there's a term in engine performance, no code diagnosis, no code drivability. And you're like, ooh, that car's got a loss of power, but I don't really know where to start. It could be fuel, it could be spark, it could be compression, it could be a clogged cat. It could be the intake air filter is totally clogged up. Like, I really don't know. But, you know, we could check for DTCs, maybe check the history to see, maybe the history gives us a clue. Maybe they just had some work done that could have caused it. And then you check for TSBs, that's kind of similar. And then you're going to say, like, are there recalls? You're kind of grasping at straws here. Are there recalls or any sort of other things? And then you're going to look more at like a general understanding of the system, right? If it's an engine related issue, and I think it could be fuel, is it rich or lean? I don't freaking know. How could I tell? Anybody think they know? Old school mechanic could smell it. Be like, oh, that's running really rich, but you can. But for me, you want to know what I'm going to do? I'm going to go in the scan tool. I'm going to look at the oxygen sensor voltage, or I'm going to look at the fuel. I can tell if it's rich or lean based on the oxygen sensor voltage. Lean is low, that'd be like 0.2 volts. Rich is high, that'd be like 0.8, 0.9, right? So like I can tell right there. Let's just say you go in there and you find out it's lean. Lean means too much air, not enough fuel. Think of the things that could cause a rich or a lean. If it's lean, not enough fuel or too much air, what could cause not enough fuel? Think of it, yeah, think of it more like not enough fuel is getting sprayed into the engine. If the fuel filter's clogged, wouldn't that kind of restrict it? That's an idea. We could check the fuel filter. Okay, what else? Maybe the fuel pressure regulator's having the pressure too low. We could check that out. But see, we're mostly going off of like our own understanding, right? There's no flow chart for this. There is none. Okay, so this is the more advanced diagnosis. It's still the onboard diagnostic system because we can look at fuel pressure sensor information. We can look at oxygen sensor. We can look at stuff, but then it's also kind of old school. You're actually checking fuel pressure. You're measuring this. Maybe the injectors are dirty. Maybe your fuel pump is worn. It's not really making enough fuel pressure, right? So like the reason I like to cover this now is you need to understand how all this stuff works together if you want to actually be able to do the no code diagnosis. If it's code diagnosis, you kind of like follow the flow chart. It's not easy, but it's not that hard. This is much harder. So there's overall fuel, ignition, mechanical, emissions, electrical. There could be like problems in any one of those and various problems in each of them. For example, right here, we're doing I think this is a fuel pressure test right there. The fuel pressure reading about 55. 55 is in spec for a Toyota. 55 is not even remotely close to in spec for a GM. GM's gonna probably be like 75, 80, 85. So you need to know the spec, then you need to check it against the spec. And if it's in spec, we're moving on. And if it's not in spec, we found our issue, right? So in that way, isn't it kind of like process of elimination? But you're not always looking for what the problem is. You're more checking off what the problem is not. Check the fuel pressure. Is the fuel pressure good? Yes. That means we're not really worried about the pump. Now, you could actually have a pump that makes good pressure, but it might not deliver enough volume. So sometimes we'll squeeze this little button and fuel will run out the bottom and we can measure how much fuel came out to see if it's actually flowing enough volume, right? But once we do our checks, we're like, no, it's not really an issue with the fuel pump. Let's look maybe more into the injectors, right? So your process of elimination, and the best you can really do is check that things are good. Customers aren't real happy when it goes to this because you're like, hey, I spent an hour. I did this fuel test, that fuel test, that fuel test. It's not your fuel system. And they're like, oh, then what is it? You're like, I don't know, but it's not your fuel system. And I spent all that diagnosis money and you need to come up with more diagnosis money. And they're like, what? You mechanics, you're all the same. You're ripping me off. It's unethical. And it's kind of like, well, I mean, you could take the car someplace else. I'm good. But you do. But the facts are the facts, though. Like, they don't. They really don't. And I try to educate people. And then sometimes they think I'm lying. But most of the time when I run into people, I'm not in uniform and we're just talking. And then next thing you know, they want me to work on their stuff because they know that kind of like I'll probably be able to take it all the way to where it needs to be to actually get fixed. But then I'm like, look, there's too many people trying to hit me up. Like, no, there's actually good technicians out there. They're just not as cheap as you'd like them to be. And they're not going to be. And if they charge so little, as little as the customer would like, then they're going to wake up one day and be like, why am I doing this? I don't want to fix cars anymore. I'm not making enough money. And then you're stuck with the ones who don't really know what they're doing. So it's kind of I stand by a lot of the issues are just people aren't that good at it. It's not that they're always trying to rip you off. It's not to say sometimes they don't, but fixing a modern thing with a problem like this is not an easy job. And I'm not really looking to pick up any more of these, to be honest with you. I'm good on that. I'm trying to help you do it. You could get paid. Okay, then let's say you repeat the repair, you complete the repair. Maybe you might have to clear codes, but if there were no codes, you could do what's called adaptives. Adaptives is where the vehicle adjusts to a problem. So for example, the fuel trim was lean, right? If we didn't have enough fuel pressure because the fuel pump was worn, now we put a new fuel pump in there, don't you think it's going to deliver a lot more fuel? Well, over time, the OBD system was adapting to your worn fuel pump. It was saying, open the injectors more, open the injectors a little more, open the injectors even more because your fuel pump's worn, to the point where it was shot. Shot's my term. You can share my term. That fuel pump was shot. You know what I'm saying? But it wasn't, it was good, and then it was less good, then it was less good, then it was less good, then it was totally shot. The adaptives have been compensating. You put a new fuel pump in there, you know what you should do? Clear it. You should reset it. When you reset the fuel trims, it's going to be like, hey, let's start over with this new fuel pump. That'd be a good thing to do. Idle's another one. If you go ahead and you clean a throttle body or replace the throttle body, that throttle body was having to open more and more to make up for the carbon buildup. And if you clean it, now all of a sudden a lot of air comes in, the idle's high, and the customer's like, what the heck? I start my car and it's, and you're like, yeah, it'll go away eventually. Well, that's true. It'll adapt back down to closed. But what we should do a reset right there. Sometimes that's like an idle relearn. Sometimes just clearing the codes, even if there are no codes, will do it. You know, so there's adaptations with the engine, with the transmission. There's stuff that's happening. After you do the repair, it's usually a good idea to reset that stuff. Cool. And then you guys are done. All right, so you got any questions? Or you good? Get burned out today? It's okay. It's normal. It's good info. It's just, it's big brain info, so it's kind of hard to